Hello, wonderful people of the internet. Welcome back to another episode of Simuleo. It's Folster, C252. Hey, thanks so much for coming in. C252, thank you so much for the 13-month subscription with, what is that, 13 Simulacres and a high? How are you? Right, yeah, thanks so much for the support. I really appreciate you being here. And obviously, thanks so much for all the help with the algorithm archive and everything else. For those of you who might be watching and you haven't been here recently, you would know that I'm having, well, never mind. I don't know what I was trying to say there. But what I'm trying to say is, if there is anything wrong with the audio for the stream, the music's too loud, my voice is too quiet, something like that, feel free to let me know, and I will do what I can to adjust it as soon as I see it in chat. But seriously, thanks so much for all the support, everyone. And let's go ahead and get started. Okay. The audio is perfect. Great. For once in my life, the audio is okay. So, what's the plan for today? Okay. So, today is Saturday. As of this morning, it seems like every single, like either Friday evening or Saturday morning or something like that, I get a note from someone in Klima saying something is broken. So the first thing we're going to do is actually fix that. I meant to do it before stream, I just didn't have time. And since I've been doing Klima stuff kind of on stream, I think it's probably okay to do that here. So the first hour, we'll say, so I guess I'll put it in 2 o'clock p.m. EDT. We'll be working on Klima stuff. At 3 o'clock p.m., we will be working on an algorithm archive review. And then after that, we'll be working on just algorithm archive development, finishing up what we started yesterday, getting all of the visualizations done, ready to go for the algorithm archive chapter. By the end of the day, the chapter should be ready to go. Let me check. Oh, that was not what I meant to do. I want to check to make sure I have quality options, and I do. Great. Okay, so that's the plan for today. So for those of you who may be coming in, you haven't seen a Klima stream before. Hello, I am Dr. James Schloss. I recently got my PhD at the Okinawa Institute of Science and Technology, and since then I've been working pretty much on Klima full-time. That's been my thing. Now, I do have some work I need to finish up for OIST. Needs to be done pretty soon too, so I'm in a bit of a bind there. So I might do another stream soon, finishing up that work for OIST. Hey Cleanstar, how are you? But yeah, for the most part, I've been working on Klima, which is the Climate Modeling Alliance, or also known as a climate machine, depending on what you're using the acronym for. So here it is, klima.caltech.edu. It's a new fancy-pantsy climate modeling engine system, something like that, written in Julia, working on GPUs and high-performance computing. There's a lot of really interesting bits to this, but the bit I'm working on right now is something that I was tagged on in a most recent PR. So let me go to github.com/ I guess Climate Machine Klima. Let me go to the most recent pull requests, and I want to say some of the pull requests, well, let me check this one as well. Some of the pull requests are failing on their Mac build, and I don't really know why. But some of them are failing on their Mac build, so I need to figure that out. So let's see. I don't remember which PR this was. I want to say it was like 998. Yeah, it's this one right here. So like for example, this build in here fails on its Mac build in here. So if we go down here, right. Actually, that one seemed to pass, but regardless, I was given some CI here that has failed for Julia. And so basically what we need to do for the first little bit is just fix this problem, right? So I'm going to explain what the problem is, and we're just going to kind of poke at it for a bit and see where we get in an hour. That's kind of where we're at. Hey, Amaras, how are you? I didn't even notice I was gifted a subscription. Nice Simulacow there. Yeah, so who was it? I think Skylius came in the other day, and she just was watching everyone on stream, and she gifted... I think 5 people sub, and then some anonymous gifter gifted to someone else. Other 5 people, 5 subs. So we have about 10 extra subs because of that. So that's probably where you got the gift from. Hey, Prutz1311, how are you? So again, this is going to be kind of complicated. Again, going into the weeds of Julia, but it's only for an hour today, so it won't be too much. And again, if you guys have any comments, questions, concerns, anything like that, just let me know, and I will do what I can to answer it as soon as I see it in chat. Cool, so let's go ahead and get going. We're going to, first of all, cd into projects Klima, ls, and we're going to git branch, and we are in master, and I'm just going to git pull upstream master. Okay. Oh, am I already up to date? Okay, so nothing was changed since last time. So let's do git checkout -b, and I'm going to call it pcg test fix. And we'll do JRS or something like that beforehand because that's the notation. That's Skylius. Yeah, Skylius is a wonderful streamer. A lot of the educational streamers are super nice. And I'm really glad that we have such a, such a welcoming community on Twitch, Supercomputer. Hey, Vexatos, how are you? Yeah, so a lot of the stuff we'll be working on today is not going to be directly supercomputing, but it's going to be touching a lot of supercomputing elements. So that's why I put it in the stream title. It's going to be mainly Julia and GPUs again, but again, a little bit of supercomputing discussion. So it shouldn't take too long. So I'm going to go ahead and cd into tests. Let's see, test, and I think I want to go into numerics, and then I'm going to go into cg dot, that's not where it is? Oh, probably cd into linear solvers, ls, and then cd into, vicg.jl. Okay, so we don't actually have to know the details of this particular example. All we need to know is that certain tests are failing. In particular, this test in here is failing. So that is to say that it smells like MPI. It is a lot like MPI. In fact, it is just MPI when we're talking about supercomputers and distributed computing. Essentially, this test is failing. It's failing on the architecture-specific array test. But all this test is a test of standard arrays. So we have this preconditioned conjugate gradient, and the way it works is, I don't have to describe what the method is, but what I have to say is that it acts on 3 different types of arrays. Normal arrays, coup arrays, which are, again, arrays on the GPU, or MPI state arrays, right? So we did a test for arrays, we did a test for MPI state arrays, and so then the architecture-specific array test is either coup arrays, if you have a GPU available, or arrays again. And I think the reason this is failing on a Mac in particular is because there is no GPU available on the Mac. Therefore, coup arrays just don't work. So we're doing the array test twice, therefore causing that test to fail due to some weird arbitrary precision issues. So what I'm going to do is I'm going to figure out a way to make it so that test is skipped on a Mac. Now, the easiest way is just to put an if statement and say, hey, if no GPU is available, we just skip that test. Is it something like actor model? Is something like actor model used in supercomputing? I don't know. Because I don't know much about those simulations. Julia test should have a flag for architecture OS. Right. We can do that. But I think the better way to do this is to look at the tests, see what we have, and to see if we can combine some of this stuff together. Because at this point in time, like, we're setting up the same, how do I say this? Each test is testing norm of x minus x exact, norm of a times x plus b. So it's the same as these guys down here, just with a slightly different x and a slightly different a. And then if we scroll down to the last test, to the MPI test, again, it's the same thing. But maybe you guys are right. Maybe the best thing to do here is just to say, if a GPU is available, we do this test. Otherwise, we don't. Maybe that's what we do. In fact, yeah, maybe that's what I do. I mean, that sounds kind of lazy, but I'm looking at these lines of code, and I think the reason we did 3 separate tests is because all these lines are different. X is 1s of n times 1.0. And it's not easy to query whether a GPU is available or not. So maybe that's what I do. I'm just going to put a giant if statement over here and say, if GPU is available, we do this test. Otherwise, we don't. That's all I'm going to do. And then we're going to rerun the tests. And it's a simple fix, but it's what we're going to do. So that's the only test that requires a GPU. Right, so it is the only test that requires a GPU because the MPI state arrays will have an array backend if we're going to be doing that. And the other test is for arrays. So this is the only one that requires a GPU, just this one. Like maybe modern alternative for MPI, like FSM actor models. I don't know. I don't know much about it at all. So yeah, if you guys have any questions, comments, concerns, anything like that, feel free to let me know, and I'll do what I can to answer it as soon as I see it in chat. So in here, I guess we're gonna say if array type is equal to let me just go ahead and run cd projects, Klima, ls here, What am I going to do? I'm going to run Julia 1.3 -- project. And then I'm just going to run using Klima and klima.init. Q, I'm so worried. Look, I mean, all we're doing is commenting out a test if a GPU is not available. In fact, there's definitely other tests that are commented out if GPUs aren't available. But I guess this is what we should do. We should say if array type is equal to array, right? Then we do these tests. Here. This is the dumbest PR ever. Oh, oops. I screwed that up a bit. Oh, that's going to be the Julia formatter. We'll pick that up. Okay, so let's see what the array type is in Klima, and yeah, see what we can do. I think this is all we need to do. It's just if array type is equal to array. But actually, yeah, maybe we should do something slightly different. Which distro and desktop environment do you use? I'm using Arch Linux and OpenBox. Thanks, Vextos. I feel like, okay, I've been thinking about it. I kind of want an OpenBox emote. I also want like an Arch emote. But the thing is, I asked the Arch developers, like I asked whoever was in charge of PR for Arch, and I was like, hey, I want to make an Arch emote for Twitch. And they were like, no, can do, because that, you know, you'll be making money off of that. And I was like, okay, that makes sense. Klima. Wait, is that not right? Klima? Okay, Klima. Dot init. Disable GPU equals true. I think that's right. And so we'll give this guy a second to go. And after it's running, we'll check array type. Dang, it doesn't exist. That's array. Array type. Where do we set array type? Device equals array type. Equals array CPU, otherwise CUDA. Yep, that's what I was expecting. So this should work just fine. So what I will do is I will now include this file just to make sure it works. So let's go ahead and do include, and we'll do test numerics, linear solvers, and test numeric linear solvers, and then what am I looking for? cg.jl. Give that guy a second to run all the tests. It won't take too long, just some pre-compilation. Klima.array underscore type. How did you know that? Oh, it's right there. Okay, fair enough. Give it a second to build everything, and then we'll try it again, specifically setting GPU equals false. Build some bridges in chat. Okay, anyway, so it didn't run. That didn't run the architecture-specific array test, and that's because I screwed this up. So if this is going to be equal to, I guess specifically coup arrays at this point. But I guess I'll do this. I'll say not equal to array. So this should run that architecture-specific array test. It does. So now what we're going to do is redo this test for disabled GPU equals true. Here. GPU equals true. And let's give that guy a go. Right. And this should only run 2 tests. Good. Okay, that's exactly what I was expecting. Great. So we'll just basically put this in, and I'll just draft up a PR with only this in there, and we'll see how it goes. Right quit. Git add cg.jl. It's like the dumbest PR I've ever... Anyway, it's fine. I'll just put it in there and be like, it is what it is. Git commit -m removing architecture. I should probably change the name of the test to be specifically coup array test. So we'll do architecture specific. Where is it? Architecture. So let's change this to a coup array test. Okay, so now we're going to do git add cg, git commit -m removing coup array test if maybe comment on it on the if statement. Yeah, I could put a comment on there. The I here, let's look for coup array here. And so test set CUArray test begin. And here we're going to say this is a test. Yeah, you're right. But the issue is I don't think CUArrays exist in the... Oh, you know what I'm looking for. I think it's CUDA.has... Where is it? Has GPU or something like that? Yeah, that's what I'm looking for. Let me go into kernel abstractions. CD projects, kernel abstractions, VI examples, and then matmul maybe .jl. And we'll do CUDA API has CUDA GPU. So let's just put that in there. CUDA API has, one second, CUDA GPU. That should be fine. Okay, so this should be fine. Sorry, what's the goal of the program? So this program in particular is, it's Klima, it's a climate machine. So it is a large-scale climate simulator, is what it is. We're still in the beginning stages of it, and we'll slowly but surely be building more stuff into it. I think I need to load the CUDA API. Yes, I need to load it up here. So I think it's just CUDA API. Using CUDA API. Caps lock was on. Come on. There we go. Nice. So if we do that, this should work. Close this out, and we're going to include that test. What? Include that test. Why is this failing? What? It is a lot of math. This particular simulation is a lot of math. So yeah, Amaras, have a wonderful evening or afternoon or whatever time it happens to be. Check whether the instance works. If CUDA API has GPU, am I doing something dumb? I must be doing something dumb. Why is that failing? It's not failing on the CUArray test. It's failing on the MPI state array test afterwards, which is weird. But we'll see how that goes. I'll just let it build, and we'll see if this works. And now specifically, this is a CUArray test, so let's go up here and just say testing for I guess this is specifically a CUArray test, although it is. The thing here is we've set it so it's like array type and all that kind of stuff, which means it could technically be for something other than CUArrays. That is to say that like you could have it so it runs on any type of array, but we'll say testing for CUArrays specifically. And now let's do git add cg and git commit -m. And we'll say removing architecture specific array test for devices without a GPU. There we go. Right. So again, if you guys have any questions at this point, I am more than willing to answer them. I think this might be what I do. I think this might be the whole PR. It's literally just removing that test for cases where you're testing the array twice. And I guess I'll just link this in here as well. So let's go here. And I guess we'll just test this on the CI and see how it goes. So let's do github.com/klima, and I'll just open up a PR. I pushed it, didn't I? Oh, I didn't. Ranch. Git push upstream jrs/pcg test fix. Okay. So I pushed that. We should be able to create a PR. Right. So we'll do compare and pull request. I'm just gonna up here. So we'll say the CI was failing for some tests for the architecture specific Oh. 4 PCG. Okay. This test for devices without a GPU, this test is the same as the array test before it, so it is unclear why this is failing sometimes, but there is no harm in removing it. Systems without a GPU. I'll just put example for failed CI on Mac. I should be able to just paste this in here. Where are we? There. If anyone has more information or can, I just don't, if anyone has, I don't exactly know why this test is failing. Exactly. All I know is that we are removing it on the devices without a GPU. That's kind of all we're doing. I guess I'll say please let me know if any other PCG or CG test. Let's see. On devices with GPUs. That is kind of what we're doing, but this test was superfluous. It's the same as the test that we had before, right? So we did a test on arrays, then we did a test on architecture-specific arrays. So this is Q arrays if you have a GPU, or arrays again if you're on the CPU. But that's the thing. So we did the array test, it passes, and then we do the array-specific test, and it doesn't. Let me take a look at this guy again. So Q array test here. And let's see. So we have AT is array type of A, ATB, ATX. It's the same as. It's the same. It's the same thing. So I'm not too worried about it. I'm gonna say if this test is failing on devices with GPUs, why that? Let's see. Please let me know if this test is failing on devices with GPUs. So just to be clear, here's our array test. It's test to norm x minus exact, norm of exact, error threshold. And then we have this guy as well. There should be a better fix for this, but I don't know what that fix is. I mean, the failure seems to come from inside of linear solve. So if we take a look at the CI test, I want to dig into it just a bit more before we close shop for this part of the stream. I realize again, yeah, it is kind of getting in the weeds a bit, but I don't mind it too much. I think this is what I do. So let's see, some tests didn't pass, and it specifically failed. Can I just control F for this? Iterations. Yep. So it says load error normal residual is not finite after 100 iterations of do iteration. This is after the architecture specific array test. No, actually, the architecture specific array test passed. Ah, crap! I'm an idiot. I was completely wrong in my base. I thought the architecture specific array test was what was failing, but actually no. This looks like a failure after that, and it's a failure in the MPI test. Okay, well, that means I just did something really dumb. That's fine. Well, that's fine. Okay, what we have is fine. It's just that that's not the main reason. It's good to do this anyway, but I'm trying to figure out what line it breaks on. So let's see if we can figure that out. It looks like it's breaking on linear solve. Conjugate gradient. Okay. Yep. Conjugate gradient, MPI, state array, blah, 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 blah. Oh my gosh. 117 on linear solvers. My word. That's an error message for you. VI source, linear numerics, linear solvers, linear solve. Oh, I guess it's linear solvers.jl, and then I think it was 117. If it's finite, of course, this is where the error is popping up. Like, yeah, of course that's right, because that's where the error message is printed. Dang. Okay, I was hoping to get some more information, but apparently I have none. P-value not significant, just add more data. Well, that's how it works. I've never actually worked in a field that has a significant dependence on p-values and stuff like that. So I'm not as good with statistics as I should be. I know I should be better. Okay, so we have iters plus equals inner.iters. And we say is finite, residual norm. Okay, so where's the residual norm? The residual norm is defined here as 2 iterations of linear solve, Q right hand side, solver threshold argument. So it's going to be in our do iteration function. And then for some reason, in some cases, now let me see. Is this the error that we were getting before? Some tests did not pass. No, expression norm. No, it's just saying that the value here is too high for some reason. Let me include this a couple more times. What? Where'd that error come from? Okay, well, VI test, numerics, linear solvers, cg.jl. What line is this on? 52? Oh, ha, that's why. My bad. I had the wrong commenting structure. I'm just gonna include this a couple times. I don't know why I'm doing this. I thought maybe part of the reason was that there was some sort of precision error that occurs when you have too much, like, how do I put this? Like, there's a precision error that happens when it runs too much. I don't know. I have no idea. My stats professor had me read this article for some homework assignment. I can just put this in my browser, right? I don't know how DOIs work. The p-value you can't buy. There's a growing frustration with the concept of the p-value. Besides having an ambiguous interpretation, the p-value can be made as small as desired by increasing sample size n. Ah, right. Sounds like chaotic systems. DuckDuckGo has a bang for DOIs. Oh, interesting. That's the article. Nice. Consequently, standard deviation... Right. Yeah, okay. I can definitely see why this would be an issue. He had us read the first 2 sections. Yeah. Okay, I understand. I mean... Yeah. I don't know what to say. I just... It's an issue. Okay. So, what are we going to do then? I can't get this test to fail, no matter what I do. Let me try specifically running this on a system that only has a CPU. So we're going to do disable GPU equals true. Include. Yep. Let's put that architecture-specific array test in again by just saying, I don't know, if true. Can't get it to fail. This is the issue. It only fails on specific systems, and I don't have that specific system it's failing on. Okay, and I asked the person who helped work on this code, or actually wrote this code. I was the one that was helping work on this code. I asked that person if he could run it on his Mac to see if we could get it to fail again. And I'm not really sure what to do here. RB Tree, thank you so much for following. Really appreciate it. So what I might do is I might just post on that PR saying that I honestly cannot replicate this failure. And the CI seems to be passing now. So I'm not sure exactly what the problem is, right? It basically says that after 100 iterations of do iteration, something is not finite. And that thing that's not finite is... Let's see, what does it say? It's... Oh my gosh, I hate this so much. Move back here. Like, who? Who designed this? Such that you have to scroll all the way over there. I mean, admittedly, this is also an issue with Julia. The error message is just being garbage. Burpee Troll Basher. Ayo, I'm from a stream you rated, so I already followed, but I'm new. Hey, how are you? I hope you're having a wonderful day. We'll be working on Klima, which is a climate machine, for the next 20 minutes or so. Just seeing where we get. Just poking and prodding at this to see if we get any more information. I'm not convinced we will. I'm a fan of E.T. James, The Logic of Science. Cool. If you don't have absolute precision, the error will accumulate. Right. That's true. I mean, this is the residual, right? So it says the residual is not finite after 100 iterations of do iteration. The norm of the residual. But, I mean, the norm is the residual. And so, let's see, what's the next error? So it says linear solve, that's one error. So top level scope, user runners work, numerics linear solver, CG 81. Just to make sure we know what we're talking about. Let's go here and let's go to 81. I'm pretty sure this is a few lines off. I added a few lines. Oh. Let me... Oh, hello. Dang it, I keep doing that. Let me comment this back in, remove that, write and quit, git checkout, master. What was changed? I added a comment. Oh no! Oh no, I screwed up big time. Let's go into VI. I left the C++ comment in the Julia code. Therefore, if anyone runs this branch, it's going to fail. Oh my gosh, how did that slip by? Okay, so we're gonna do VI test CG, fix this up so the GPU is enabled again. And we're gonna do git add test whatever star git status. There we go, git commit -m, fixing commenting style. Oh well, that's what happens when you have an idiot programming. Git log, what do we have here? Q, git rebase -i, head 2. Let's see, I want to squash this. Yep, right, quit. Just gonna remove this guy here, remove that guy there. Git push upstream. Actually, git branch really quick. Git push upstream. JRS PCG test fix. I need a double dash force. There. Now no one's ever gonna know I was an idiot because no one's gonna check the branch anyway. So let's do git checkout master, and let's just run this test one more time. Control C. Yep, of course everything passes because we're not on the system that would break. So now what do? We are going to go into this file and check line 81. It is on iters linear solve. That's exactly what I expected. So this function is failing with an MPI state array. Linear solvers, iters linear solve. If I could just replicate the error. Then we could go a bit further, but at this point I can't even replicate it because it only happens on a Mac apparently. Okay. So I guess I'm just going to go in here and I'm just going to say, look, I'm just going to go in here and say the Mac CI seems to be passing now, and I genuinely cannot replicate the error at this point. I guess this is what we have to do. I know it's super lame, but it is what it is. So max CI seems to be passing now. I genuinely cannot replicate this error at this point in time. Could we get a list of... I guess I'll say I will look through other failing PRs to see if... Oh, I'll say any other. Yeah, that's the best I can do for now. Just go through the other PRs and see what we can do, you know? Oh well. So let's just go through the PRs that are live right now. If this is a persistent bug, and not just a bug with like that particular run, then we should see the same issue in these guys' CI as well. So I'm just gonna look at their CI. Let's go here. Nope, all of that passes. Again, it all passes. 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 I can't. I have no idea. I'm at a complete loss here. Let's see. Let's see. Yeah, let's see. So one of my friends is looking at this problem right now, and he just said that maybe MPI_B is being initialized as 0 on the machine. So let me see what we have here. Let's take a look at this guy, MPI_B.data. So let's go down to, this is the MPI test. So MPI_B.data is going to be dot equal to array type. Oh, you know what? No, there was no reshape in MPI_B, was there? Dang, I thought maybe there was an issue with broadcasting. So let's see. So you're live streaming your day job? A bit of it, right? I mean, just like an hour or so a day. I'll be doing more algorithm archive work in just a bit. In about 10 minutes, we'll switch to the algorithm archive stuff. But for now, I just kind of wanted to do a bit of Klima development. Honestly, some people have seemed to get a lot of information from this. That is to say, there have been quite a few people who've come onto the Klima stream, and they have enjoyed their time, and they have learned a lot from it. So, oh, okay. So my friend just replicated it, but it happens randomly. Okay, right. So he said he was able to reproduce the error, but it happens randomly. And I said, right. I don't know. I don't know. I have no idea how to figure it out. So at this point, if it happens randomly, maybe we just leave it. Hey, Lol, how are you? Did you fix the seeds? Yeah, the seeds are fixed. Up here, we set the random seed to be 1, 2, 3, 4, 5. It doesn't matter. It's just some seed. Happens randomly. Sounds bad. Right. But right. So there has to be a hardware reason why it happens randomly, right? Like we have a random seed initialized. So there just has to be some reason why it... I don't know. I'm just lost. Oh man. Yeah, I'm just completely lost. Let me comment on my friend. 1 second. He sent a message saying that he was able to replicate it. I'm just gonna say I'm at a loss. I am at a loss. That's all I'm gonna say. I have no idea. I can't replicate it. Dot equals is slice assignment. Right, it is, it's like a broadcasting operation. So dot equals means you're setting each individual element equal to whatever it is that you're putting in there. So let's take a look at the MPI test and see if we can find any information. So again, my friend with the Mac was able to replicate it, but apparently it happens randomly, which is what we also found. The CI only fails at random. So we'll say MPI method. So we have MPI_B.data. I could just run this test in the REPL and see what happens, right? Like, what's the worst that could happen if I just run this in the REPL? Walsh9 and the Velvet Soldier, thank you so much for following. Really appreciate it. I've just arrived. What's the matter? Right, so for those of you who may have just come in, I'm working on Klima, the climate machine, and basically there's a test that is failing on the Mac CI sometimes. Not all the time, just sometimes. This is way over my head. It's neat to watch. In about 10 minutes, we'll move on to something that may be more in your head. It's a bit more visual and a bit more understandable. This is really just going down in the weeds of the Julia ecosystem, trying to figure out how it works. That's bad? Right. So it only fails sometimes, right? For those of you who don't know what CI is continuous integration. It's basically every time you put code up on GitHub, continuous integration just runs the code's tests essentially, just to make sure they pass. And this particular test is just failing sometimes. And that's where I'm lost. So let's see, MPIB is going to be, so this test passes. So we're at this stage, beyond this stage. So we have MPIB is MPI state array. MPIX is MPI state array. MPIA is array type rand n 4 to the third, 4 to the third. MPIA dot equal MPIA transpose dot MPIA. I'm not seeing anything crazy about this. Wait. Cool. So now we're ready to answer CI related interview questions. I don't know. I thought, some people here are at different levels of understanding of programming, right? So some people may not have touched CI before, so I just wanted to make sure people knew that when I said CI, this isn't on my own machine. It's just on some machine in some server somewhere. Let's see. Hallmark Shells, thank you so much for following. There's a concurrency issue. Sounds like a concurrency issue. How would it be a concurrency issue? I'm pretty sure that's a concurrency issue. But how? If you can give me an explanation for how, because I'm not seeing it. I mean, maybe it is. I don't understand it. So let's see. MPI multiplied by. So we'll do f of x is MPIA. One thing I don't like about this particular function is that MPIA is in the global scope of this function, or like the slightly bigger local scope, I guess, which is a bit weird. But that's not a big issue. So what I was saying when I say this is MPIA is not in the function arguments, right? But x and y are. Also f of x. No, f of x defined there. So we could maybe we just move on. MPI method is conjugate gradient. Linear solver is MPI method, MPIB. Iters is linear solve, MPI mul by linear solve. It's failing here at this line right here. Nope, sorry about that. It's failing at this line. So why would it be failing at that line? It's failing because the residual is non-finite after 100 iterations. That's the exact error that we get. Now, why is that the case? Why would the residual be not finite after 100 iterations? Well, that would just mean that your residual was probably above 1 at some point, and then every time you multiply by the residual, and it eventually becomes not finite. Something like that. Exponentially grows beyond what we can hold. I mean, the residual could just be very large. What is the normal residual? Let's quit here. I'm not sure what I did before, so we're just going to quit out of this. And let's do git branch, git checkout, JRS, and then we're going to do PCG test fix. PCG test fix. Okay, so we're in the right branch now. Let's go into VI source, numerics, and then linear solve, linear solvers.jl, residual. So we have this guy, iters plus equals, where's our error, normal residual, if is finite. I'm just going to do this is really dumb, but we're just going to do print line of residual norm. Write this, go over here. We're going to have to recompile. Write this, go over here, Julie _project, include, let it recompile, and then we'll go there. Nan is also not finite. Right, that's what I was saying. It's so large that it's a nan. Or it could be divided by 0. But where are you dividing by 0? Would that mean that... Yeah, I'm not sure. Anyway, we're outputting the residual to see if it gets, like, super large or something like that. Just log the residuals. That's what we're outputting right now. The solution does not converge. Well, from experience, Bugs that appear randomly have two possible causes: an uninitialized variable array or concurrency. I suppose Julia initializes everything, so I believe it's concurrency. I thought, yeah, but we're not. Yeah, well, okay, we'll see. We'll see. Let's see. So apparently he figured it out. MPI data arrays are sometimes initialized with nans in them. They are randomly initialized, thus the erratic behavior comes from not specify MPI x. Thus adding the following MPI x data would fix the test. It doesn't always happen, but it's the only source of randomness in the code. What? No. No, tell me you're joking. One second. Oh my gosh, that's ridiculous. What? Okay. So, MPI x.data. No. You kidding me? Man, if concurrency, then we should be able to get the result on non-parallel version. Right, that's the thing. I am not running this on a non-parallel version. So, let's go into the test here. And what we need to do is MPI underscore x here is equal to that. And then what do we say? So MPI x was not initialized like MPI b was. So this means, oh my gosh. Oh, this is so dumb. So we'll just change this. So it's MPI x.data. Write this, make sure that it passes. Let's write this, Control D, and then we'll do Julia 1.3 double dash project include, and this will be our PR. Okay, so we'll just say we have to initialize them. MPI x was potentially initialized with nans already in it. That's what we'll say. That's a bigger problem. So MPI state arrays are initialized with whatever was in memory at the time, therefore nans. Okay. Okay, well, anyway, I have it fixed. I will co-author this with Andre, who's the one that helped me. So I was correct, we'll see. Is this... Oh, well, okay, right, you were correct because you identified that the randomness was the error. Julia, well, that's exotic. You mean like an exotic programming language? I would argue Julia is very far from being exotic. But we'll see. So that passes. As long as all the tests pass, I'm happy. And then we'll put the PR in. Yeah, that has to... Yeah, okay, that's fine. This has to be the issue then. Okay. So I'm going to run it one more time just to make sure. Seems to pass okay. So let's go ahead and do it. Git add test numerics linear solvers cg.jl git status git commit -m adding, how do I put this, initializing MPI underscore x to be rand like MPI underscore b. Oh, I should do git commit, and then I should co-author. So git log. Where would we have co-authored by? I'm looking for a co-authored by Andre. So I don't remember what his GitHub moniker is. How long ago is this? April 21st? What day are we today? We are 26th. I don't know if I'm going to be able to find this or not. We have a bunch of co-authors of this particular PR that I'm looking for. So I'm just scrolling down to see when this could have happened. Co-author. Ah, there it is. That's what I'm looking for. Nice. So we'll grab this guy. Open this. Paste there. Fixing MPI X to be initialized as random, like MPI B. Okay. Okay, so we'll do git what am I doing? Git commit. No, git rebase dash I head minus. Oh, let me also run Julia formatter. Julia.dev format.jl just to make sure that nothing changes. And we'll just go from there. Yep. Anyway, it's found. 25th, thanks for that. I love when there's simple fixes like that. Julia sounds like an academic language. Maybe it is an academic language, but it is, maybe it is mostly an academic language at this point in time. But it's incredibly useful for high performance computing, which again is very academic at this point. So I do understand if you want to call it an academic language, but I will say that it's really good at what it does. It's almost as fast as C. Really great at working on GPUs. There's a lot of good things there. You know, I write Haskell. Oh, in that case, that's way more academic. Git commit m formatting. Okay, so git rebase minus I head 3. And we will squash and squash. Let's see, this is a combination of 3 commits. I don't think I need that. Removing this. Co-authored by Sandreza. Nice. Oops, sorry. And then we'll just do 1, 2. Okay. And we will do git push. Upstream JRS PCG test fix force I misspelled test. Okay, let's go. Okay, so now we'll create that PR and we're good to go. Let's see. I will. Okay, so let's go ahead and put this PR forward, and we will just go in here and we'll say, I might have to F5 this. Checking mergeability, able to merge. Right. So we will put in here and we're going to say potential fix for PCG test. Misspelled potential, but we'll go from there. Potential fix. The CI for was failing. Let's see. For the PCG test, this seems to be because the MPI X variable was initialized with nans already in it. This fixes that. And also, what do we want to say here? So this fixes that and also sets the architecture specific array test to no longer run when arrays have already been tested on CPU only devices. Example of this. Okay, so now the next thing I want to say is we might want to talk about how MPI state arrays are initialized with whatever is in memory. Is there a way to start them? Yes. Maybe they should start as all 0. Okay, let's see, what do we have here? I think you should create some tests before passing input to the function, so you know if the X is initialized. Let's see, work on state arrays. Let me go ahead and catch up with chat here. I'm super far behind. If you don't initialize variables arrays, they're potentially full of crap, so behavior is undefined. 25th, thanks. So I know things about academic languages, right? I think you should create some tests before passing input to the function so you'll know if the x is initialized. This fixes it by, I think I wrote this fixes it by doing what? Hey MRS, how are you? Would you really initialize it by default with nan? If yes, it should fail every time. No, just some of the values were nans. Yeah, some nans, I guess. Okay, do you have a PhD? Yes, I have a PhD from the Okinawa Institute of Science and Technology. So, yeah, I just finished that and now I'm working at MIT doing climate simulations. That's what we're working on. So I will just go ahead and put this PR up. I think this is what I'm looking for. And we should be good to go from there. By the way, I think I missed a follow from... I don't know if I did. Nokengay, thank you so much for following. Hallmark Shells, I think I said thanks for following, but I may have missed. I'm pretty sure I said thanks for following for Velvet Soldier. So it can explain the random failures. MIT is cool. Watching a lot of lectures from MIT. Does MIT pay well? I mean, postdocs don't really get paid too well. They get paid okay. Like, it's fine. I have enough to live in Boston, but it's not an incredible amount. So I'm actually a bit, like, I'm able to survive. I'm doing fine. But I don't really like the place I'm living at, which is why for coronavirus, I actually, like, drove all the way down to Alabama and just, I'm in Alabama. That's where I am right now because I just wanted to get out of Boston. So, I mean, it's fine. Like, MIT is fine. I love, the job is fine. The people working there are great. It's fine. It's just that, like, you know, you were in the ghetto. No, I wasn't in the ghetto. It's just that, like, I don't know, like, there's just so many weird things about my apartment. Like, the downstairs neighbor is super loud all the time. The upstairs neighbor is even louder, but intermittently. And every time I ask him about it, he's always like, well, I'm being very loud now because I'm drunk. And it's like, well, look, if you're drunk, like, that's not an excuse for being super loud. That's like the worst excuse for anything, you know? And then, you know, I'm fairly certain my downstairs neighbor is using my electricity. I don't know. Like, I'm fairly certain of that. And there's, you know, when I moved in, there was like a roach infestation, which was pretty bad. So we had to get it fumigated. And then after that, there were like a couple other things that happened. It's just a lot of just, I just don't like this place. Like, everything that could have happened, that could have been bad, basically happened. And I'm like, man, it's pretty bad. Like, it was so bad that when I told my girlfriend about it, she just started laughing because she's like, this is like the worst situation I've ever heard for housing. And my dad went to MIT as a graduate. That was like 50 years ago. So, okay, I'm gonna be honest. MIT is fine. My house that I'm living at is not. MIT is actually pretty good. Big fan of my job, big fan of the people I'm working with, big fan of all that kind of stuff. It's just a place I'm living. Like, my actual apartment that I'm in is not good, which is why I'm no longer there for now. And then I'll go back later. If they paid you big bucks, it wouldn't be a problem. Again, the money I'm making is fine. It's enough. You know, it's just that I chose to live without roommates because I figured I'm a postdoc. At this point, I should be able to live without roommates. And there were so many places available. And this is just the place that I happen to land on. Anyway, let's go ahead and get this PR in. Written and run all necessary tests. Yep, this has been done. Followed all necessary style guidelines. Yep. Updated documentation to reflect the changes in the PR. I can't check this one because we didn't technically update the documentation, but it's all right. So let's see. We want to do labels. I guess this is a bug, and I guess we're gonna do. What else can we fit here? Diagnostics, documentation, draft, duplicate, GPU. No, I think it's just bug. Linear solvers maybe. Okay. Projects, milestones. I think the rest we can just create the pull request. Oh, we want to link the issue here. What was the issue again? Let me find that pull request. PCG test. The pull request should have been 998. Yeah. Let's say in 998. Okay, so let's create that pull request. And that should be fine. So let's see. And it should be with Andre. Great. So that should all be solved. What's your PhD about again? So I worked on, I can show it to you guys right now. So if we go to github.com/LEIOS, and then we'll go to thesis. My title for my thesis was, let's see, it should be finalthesis.pdf. It should be massively parallel split-step Fourier techniques for simulating quantum systems on graphics processing units. So my thesis was on a mix between GPU computing and quantum physics. So that's what it was. So let's see, I should be able to give this now to my friend over here. So we'll say, okay, cool. So that was my thesis. Again, I finished it in December 2019. And on January 6th, 2020, I started my job at MIT. So I've been at MIT basically this full year. There's still one last paper I need to finish up from OIST. I will probably do a live stream soon about that. I don't know why, but I just don't have the motivation to do it. And a lot of times this live stream is a way for me to get that motivation to do it, you know? Like, it's weird, but like, doing it live means that I'm not going to be distracted by like YouTube or Twitch or, you know, weird manga online or something like that. Like, it means that, sure, I might be distracted by chat, but we have an overarching goal. We're going to work towards something, and that's what we do. So, yeah, okay. I am happy enough with that. Weird manga. You became a doctor of philosophy? Well, yeah. Did you get pay raise once you get tenure? Right, so I guess before moving on to the next topic, let's talk about the academic system. Let me see what else I missed here. If they paid you the $100, you wouldn't be a problem. In Japan, they didn't have roaches. Yeah, not really. Why didn't you get a studio in some high rise? This was the closest thing I could find to a studio, at the time. So, yep. Let's see, what's your PhD in? We're only a distraction. No, you're fine. You're not a distraction. You guys are actually super helpful sometimes. So let's talk about academia real quick. Academia. Okay. So how does this work? How does this work? First you get your PhD, right? This is +5 off of an undergraduate, right? Then you do a postdoc. Okay? That's +5 off of a PhD, off of a PhD. Then finally, if you're lucky, you know, you'll have maybe a 10% chance of becoming a professor. But wait, it's not a full professor. You are an assistant professor. And then you're going to be in this position for 5 years before you're an associate professor. And you're in that position for, we'll say 3 years, I don't know, something like that, before finally you're a full professor. And then this is forever. So you get your PhD, 5, 10, 15, you're at about 20 years before you're a tenured professor, right? So if you're asking, do you get a pay increase when you become a tenured professor? The answer is yep. But also, like, very, very few academics actually get to this level, right? You have to think, I mean, how many people get PhDs and move on to postdocs? That's, I think, like, I want to say it's like 40% maybe do this. It's probably less. It's probably less than 40%. I don't know the actual metric, but it's less than 40%. I know the metric here is roughly 10% can become professors. So, like, you're not really going to be going down this path very likely, right? So when you get tenure, you're right. Yeah, you get a pay increase. It's just like any other promotion or anything like that. But it's not easy to go from PhD to professor. You're still 15 years out, you know. So let's see. You became Doctor of Philosophy. Not to be distracted by Twitch. Since we're super helpful, can we put assisted at MIT? I don't know. There's also always one professor per organization, so including associate. And is there always one professor only per organization? No, there can be multiple professors per organization. In Germany chemistry, you get your doctor natural in 3 to 5 years, and then you do 2 to 3 postdocs. Then you can become a junior professor. Then you can become a full professor. Right. So 3% of PhDs become assistant professor. It's something like this. It's a very small number. You could also end up becoming a lecturer. So that chart is saying that if you make it to tenure, then you live forever. Yeah, unfortunately that is the case. I say unfortunately because honestly, you don't want to live forever. Trust me on that one. I've lived for the past 200 years. It's not nice. Like there's a level at which it's just not worth it anymore. You don't want to live for 200 years. It's not worth it. I don't know why I said that. I'm sorry. I don't know what I'm talking about. So what is course coordinator? Do you think the professorship ladder in academia is a pyramid scheme? No, it's not a pyramid scheme. It's like the opposite of a pyramid scheme, right? So let's do journal, new page before, right? So a pyramid scheme, you have this guy, you get 2 people involved, they get 2 people involved, they get 2 people involved, so on and so forth, right? So here's your pyramid scheme. As a professor, you're here, right? But it's different because professors don't recruit people. So they aren't recruiting people under them. What's happening is the other way around. You have a bunch of PhD students, and they all want to become professors, right? So then they trickle down to postdocs, we'll say, and then those trickle down to assistant professors, and those trickle down to professors. So it's the opposite because, in my opinion, the incentivization, there is incentive for this guy here to recruit people down here, right? Whereas here, the incentive is going the other way around. People from the bottom want to move up. It's a funnel? Yeah, I think a funnel is probably accurate. Living forever means gathering expertise forever. Still looks attractive to me. For some reason, I know just as many fewer postdocs as professors at my university. That's because there are probably fewer postdoc positions. I mean, you have to think about it, right? The postdoc is purely a research position. And this means that you need to have room. You have to have a place to put a pure researcher, right? So in that case, you need to find the funding for that person. For professors, you can usually fund them via their teaching that they do, right? At the very worst. But for postdocs, you have to have some sort of grant funding come in to fund that postdoc, right? So if you're not at like a tier 1 research university, it's sometimes difficult to find that funding. And even at those universities, it's difficult to find that funding. So you're going up, not down. It's a reverse pyramid. The evil academic funnel. It's a sieve. I think it's sieve. You filter and filter out and filter out. Right, that's exactly what it is. In fact, it's been called that multiple times. But yeah, so my friend just sent me a list. He just sent me some code and basically said that MPI state arrays are initialized with 3% nans. Civ. Okay, I probably should have known that. Okay, so that's it for our MPI state arrays bit. Let me see. I missed a few follows here. RoboSmiles and It Junior Pliskin. Thank you so much for following. Really appreciate it. True or false? A professor can produce a maximum 1 professor in the next generation on average. Oh, that is a good question. Can produce a maximum of 1 professor in the next generation on average. No, that is false. Because there are more academic positions now. Maybe on average. I don't know on average. I know that my particular advisor has multiple students that are professors and now. So I guess we could model that, right? So journal new page before, we have some demand for the number of necessary professorial positions. Billy EQ, thanks for following. So I don't know how to model that. I have to think about that. In France, it's 3 years PhD, some postdocs, and then you may become a professor or researcher, and then you may become a higher ranked professor. Right, that's about what I was thinking. I should know I've been to quite a few college hockey games. Both are correct pronunciations. Premium 7, why would that be true? On average, there are more professors than in the past, right? Yeah, there are more professors, but those jobs are being taken faster and faster. And I guess it depends, right? Like, what is our need for education, right? If we draw a logistic curve, right, which most things are somewhere on this logistic curve, you know, there's some sort of growth. So there's this, let's call this the growth of the population. So this is population, right? And you could argue that education loosely follows this curve. The need for education roughly follows the population, but probably slightly less, probably something like this, right? Specifically the need for higher education, so we'll say professors, right? So as the population grows, you obviously need more professors. So the question is, where are we on this population growth curve? I would argue And I think we're around here. We're actually kind of nearing the saturation point for most places. Like there's obviously India and China and places like that that are very rapidly growing in the number of professors that they need. But for most Western countries, again, the US, Europe, places like this, even Japan, I would argue we're actually tapering down on the number of professors that we need. So if most professors got in here, I don't know, I'm just making this up at random. If most professors came in here, but now we're here, then the average should be less than 1 per professor. And I think maybe that's true. I think maybe in average it's less than true. I don't know. I'm just kind of modeling something. I don't know how correct this would be. If the number of professors is increasing, then more than 1 professor per professor produced, right? Yeah, but that's if it's increasing, which I don't know if it is. In Europe, it's a master's required for a doctoral study. Right, in Europe, that's true. So the 3 years after, the 3 years you get the PhD is correct, but my 5 years is 5 years since undergraduate to get the PhD. So that number is still about right. When you have organizations like Head Gordon Group at Berkeley who produce multiple professors a year, at Event Growth, also Simuleos, I was thinking it would be really funny if you still did the Easter video and put it on YouTube, spend the whole video calculating the date of Easter, and at the very end, calculation reveals that you missed the date. No, I think it's best if I put it out next year. I know that sucks, but I think if we put it out next year, that will be best because then if we put it out, then people will be Googling when is Easter, and I think that's fine. Back in the olden days, a bachelor's would have been overkill. Now it's pretty much expected. That's true as well. So yeah, maybe because of that, more professors are necessary as well. The BMD organization demands a master's for doctoral studies. Let's see. How would you prove this? I don't know what this is. Also, what is sermoned? Sorry. There's my thesis. Go here. Oh, I don't have any idea. Let A between 1 and 0 be the set of real numbers with a decimal expansion containing only 0s, 2s, and 5s. For example, 2/9 is 2222 within A, and 2500 is 525. It's also within A. But 1/8 is equal to 0.125, not A. Prove that A is uncountable. I don't know how to prove that at all. Someone might be able to. I'm sorry about that. As long as the population is growing overall, so will professors, in my opinion. Yeah, I think you might be right. You might be right. I might be thinking about this incorrectly. Yeah, I'd buy that. Okay, Cantor diagonal argument. Nice. Maybe, I mean, other people know more about this type of stuff than I do. I'm not a pure mathematician. I'm very bad with proofs. I need to get better. Trash Talk wants to put proofs in the algorithm archive. Why don't you belong to the Knowledge Fellowship on Twitch? There are several interesting streamers like Professor Melko. Oh, I thought I was part of the Knowledge Fellowship on Twitch. I'm not a part of the Knowledge Fellowship? What? Oh, I didn't know that. Because I totally, I'm on their Discord, and I'm part of their, fellows. So, I was 90% sure I was part of it. So now you're making me question. I thought this whole time I was in with the cool educational people on Twitch, but now I'm maybe I'm not. Maybe I'm just can you prove that you're part of it? Well, screw them. If I'm not part of it, I'm not going to do any more educational content. From now on, we're only playing Guild Wars. I'm kidding. These guys are great. I just don't see it in your description. Yeah, it might not be a part of the official organization. More population is more economic growth, more taxes, more funding for professors, more professors even accounting for population growth. Yeah, I think you're right. Don't forget to change the wiki once your pull request is merged. What pull request are we talking about? What? Okay, we're gonna move on to the next bit of today's stream, which will be it will be working on the algorithm archive, finishing up some visualizations. There we go. Visualizations we were working on yesterday for the algorithm archive, and hopefully getting this chapter for the iterated function systems out. Well, maybe not out, but ready to go out. You know what I'm saying? So it depends on how long it takes to get these visualizations in, but I'm pretty sure we can get it done. So let's knock it out. I'm gonna have to change the video description really quick. Let me do that. So I guess we'll call it, what are we going to call it? It will be, wait, what are we going to call it? Bye-bye C++ time? See ya, Freeman. I know you're only interested in Julia. I still think it's interesting, the stuff we're going to do, but I understand if you're only interested in Julia. Valorant keys. I don't know what Valorant is. But no, I don't like distributing keys because it's not secure. Let's see. You construct a number that differs from every other number in at least one place. I think that would work. Oh, yeah, interesting. I have to check if it works. Yeah. You mentioned Guild Wars. My biophysical chemistry professor admits he often spends way too much time playing Clash of Clans. Nah, Guild Wars is I kind of want to play Guild Wars on stream. I have some really, like, the thing about Guild Wars is it's a deck building game, right? Like, it's an action RPG, whatever you want to call it, but it's a deck building game. Like, the entire purpose of Guild Wars is to come up with the craziest build you possibly can, and just to play that game, play with that build. I've got a Paragon using daggers, shouting and burning everyone. Like, it's the weirdest build I've ever made, and I'm like, this is brilliant. Like, sure, I don't make good builds, but I make fun builds. Like, really fun builds. You know, I have beaten the game multiple times with multiple characters, and I have never once, I have like hundreds of builds just for the Paragon, like only for the Paragon. I've got hundreds, if not like, well, maybe not 1,000, but I definitely have over 100 builds for the Paragon, and it's ridiculous. I lost all of them when I switched computers, but I've slowly been building them back, and it's super fun, because it's just like, if you think of some crazy combination, like that's what I do. It's just something's dumb. It's just the stupidest thing you can come up with, and bam, that's what I do. You know? Like, it's fun just because of that, you know? And that's why I want to do a stream on it. You know? I just want to be like, hey, this is how I play the game. I'm hoping it's fun for you. You're doing combinatorics for fun. That's kind of what I'm doing. Like, I spend more time on the wiki than I do in the actual game, because I have a list of every single skill in the game, and I read through them all, and I was like finding synergies between them, and I'm finding ways that you can play it on the Paragon. Oh, it's so fun. It's so fun. Guild Wars is the game. It's Guild Wars. I bet you if we go on Twitch, there's no one even playing this game right now. If we go to Guild Wars right here, it's probably has less overall viewers. Oh, 109 viewers. Content restricted. What? Why is my content restricted? Under what situation? Under what situation would my content be restricted? What? What? Don't give me that. Okay, good. I was really trying to figure that one out. Okay, Doombox is streaming currently. Right. Anyway, I'm sorry. It's called Guild Wars. I actually might play it on stream a bit. I've considered it. I might do it after we get the Algorithm Archive article out, because some new stuff changed in Guild Wars recently. And right, I'm just considering playing it on stream. Isn't there a Guild Wars 2? There is a Guild Wars 2, but I don't find it as fun as Guild Wars 1, so I tend to just play Guild Wars 1. Anyway, changing the stream title. Also, let me check my... Okay, good. So let me change the stream title, and we'll go from there. Make sure you get the new elite skills. Oh, you can always get the elite skills, actually. So the way you get the elite skills is by getting like a particular item in your inventory and going somewhere. So as long as you get that item, you can always get the elite skills. You just have to get the item. So I have the item. I have at least the Paragon elite skills, and I might get the other one soon. Let me change the title really quick. So, Fractals and Chaos games. Done. Okay, so the name should be changed. It should be Fractals and Chaos Games, Algorithm Archive. So let's go. Pretty excited. Okay. I'm happy that this PR seems to be in. Like, this was something that basically every Friday, like, somehow that particular PR that we put in, the preconditioned conjugate radiant fails. And like, we've never been able to figure out why until now. So I'm pretty happy that that's in. And let's go. CD into projects, Simuleos, and we're gonna go over here, CD into projects, CD into projects, Simuleos. Okay, let's talk about what we're doing. First, I'm going to open up a terminal, and I'm gonna put a visualization on screen because people like visual things. That's what I heard from Twitch Camp. let's move over here, and we're gonna run mpv projects, simuleos, fractals, and then video.mp4 loop 0. Okay, so what we're seeing here is the Sierpinski triangle. You guys have seen the Sierpinski triangle before. I'm like 90% sure this is something most people here have seen. In particular, what you're seeing is something called a chaos game. I'll describe what that is in just a second. The point is we're going to be modifying this visualization to make it be slightly better. That is to say, we're going to be making it so it is a little bit more visually intuitive. Because right now, what you see is a triangle appearing on screen. That doesn't explain to you in any way how this triangle came to be. So what I'm going to try to do is I'm going to try to explain in a more intuitive fashion how exactly this appears. Anyone else seeing more than one triangle? Also, just realized I promised myself I was going to do one review for the algorithm archive every day before doing the algorithm archive stream. So let's go to github.com and let's go ahead and do a review right now, and we will go from there. Let's just close this thing. I understand I can add more than one. Okay. So what kind of pull request do we want to do here? We have major restructuring. We checked that out yesterday. We have Rust, adding comments to existing. I could probably do this one. Runge-Kutta-Fehlberg method. Let's go here, because this one should be relatively straightforward to fix. Oh, actually, is it fixed? So it looks like he already approved the pull request. So we can just pull this one in. So let's do files changed. Yep, this all looks good. That looks good to me. 3 to 13, 18 to 25. Is that correct? It should be 3 to 13. That seems fine. Actually, should we change it? Yeah, I think this is fine. 18 to 25 should also be fine. The rules for generating the system can be simple, but you're not going to be able to figure them out. Are we talking about Wolfram's recent, theory of everything thing? Because that was super interesting, but I understood none of it. Literally none of it. Sorry, well, maybe some of it, but not much. So I think this is ready to go. All I need to do is build it locally, just to make sure. One change requested. Was that my change? 17 to 25, 10 to 24. This is outdated, so this should be resolved. And let's go to all checks have passed, command line instructions. Right, so let's go. So all we have to do is get pull, HTTPS, whatever. We'll pull it from master. Okay, let's go over here. CD projects, algorithm archive. Oh, here we are. And it will do whatever I just grabbed. This guy. Oh. I accidentally put it in the wrong terminal. That was completely my bad. Okay. So now we're going to do it over here. Paste those 2 lines again. Ah, crap. I have to get the 2 lines again. Ah, boy. There we go. Get pull. Right, so now we should do write and quit. Yep. Oh, no. Oh, well, whatever. Get book serve. This will probably work. I don't know. Let me catch up on chat. Fixed it in less than a month. I just had a bug today and found a 2-year-old GitLab issue with a solution that didn't make it to master yet. Oh no, I'm so sorry. Talking about your triangle projects, the rule for generating a system can be simple. Yeah, that's kind of what we're working with here. My impression is Wolfram is a lot of hand-waving BS. I don't want to say that, because Wolfram's an incredibly intelligent person. But I've heard this opinion multiple times, and I don't know enough to be able to say what is right and what is wrong about it. Let's go here, and I believe the comments were in Euclidean algorithms. Let's go to the Euclidean algorithm. Where are we? Should be here somewhere. Physics solvers. Euclidean algorithm. Comment. Seems to end on time as well. I don't like that, but it is what it is. Cool. Okay, I'm happy with this. So I think we can... Why is merging blocked? I was the one that requested these changes. And approve changes. Should be approved now. Because if I'm the only one blocking it. And I just checked it. Let me check it one more time just to make sure. So we want to again go to the Euclidean algorithm. Where are we? Euclidean algorithm. Here? Yeah, it seems fine to me. Scroll down to this file. Yeah, everything seems fine. Cool. So squash and merge. Right, squash and merge should be fine. Confirm squash and merge. And there we go. Thanks a bunch for this. Good work. I feel like I'm always too excited. Like whenever I like merge things in the algorithm archive, I'm always like, oh, thanks a bunch, man. You're doing great. Keep up the great work. And I mean it. Like I genuinely do mean it. But I feel like it comes off as me being facetious, you know? So I sometimes am a bit afraid of that, you know? When will you do algorithm archive PRs? I am doing algorithm archive PRs. Let me catch up on chat here. Ronnie263, thank you so much for following. Really appreciate it. But that's just my impression. I have no idea what he talks about either. May sound like that, but who knows? Maybe something could come of it. Too many screens, can't understand anything. I'm so dumb. Ronnie, you're not dumb. If you're here, you're not dumb. If I'm doing something that you have questions about, or you're trying to learn more about, ask questions. And I'll do whatever I can to answer it as soon as I see it, right? I do totally recognize that a lot of the comments, a lot of the things that I do here on stream can be very, very complicated. So if you have questions, comments, concerns, anything like that, just let me know. And I'll do whatever I can to answer it as soon as I see it in chat. Let's see. Yes, Euclidean algorithm is find the greatest common divisor. Yep. And multiplicative inverse for con mod. Don't know about this one. You can give the man credit for taking a swing at a problem. Right. Are there crypto algorithms in the archive? Is that legal to leave the US with this? So Licked a while ago did put up a PR for cryptography, and we weren't able to merge it because I'm an idiot and I wasn't able to get to it in time. But we'll be going through it soon. Let's see. You've got to give the man credit. Yeah, but what bothers me is he seems to have a huge ego. That's actually what a lot of mathematicians say. They say that the reason they don't like Wolfram is because of his ego. I hate squash and merge. It should be illegal, but I said that before. I understand that a rebase, like, it's probably better if we just have people rebase. And probably in this case, rebasing is probably a bit nicer. However, squashing and merging is way easier for new contributors. And the way I see it is we have a lot of new contributors here. And a lot of people also reviewing the code, and therefore they have to continually pull the branch. Which means that if you have a rebasing scheme, people will continually, will just continually be rebasing. Merge commits are the only way. So, I don't know. I agree that it could be cleaner, but I'm relatively happy with this workflow. See notifications, at mentions only. Let's see. So far as I remember, there is an extended Euclidean algorithm to find inverse multiplication. Oh yeah, maybe. That'd be interesting. We should probably look into that. Hey, squash and merge. Getting a bunch of Discord notifications. Lol. Oh, I'm sorry. Set notification setting at mention only. 100% agree. Drives me nuts. Let's see. But yeah, he's super intelligent, no doubt about it. I may have used it actually. How much do you get paid? Not so much. I get paid enough to survive in Boston, but not much more than that. Not enough, Mr. Cherry Buster. That's a rude question. I don't think it's a rude question. I think it's a fair question. Like, if somebody wants to be a researcher, they probably want to know how much postdocs get paid. It's not much. It's slightly more than a PhD student. The PhD students in Boston get paid $45,000 a year. I get paid $60,000 a year. That's what I actually get paid. The median salary in Boston is $50,000 or something like that. So I'm above the median, but I mean, again, it's not much in Boston because Boston is expensive. So, let's see. How is it rude? And even more illegal. Merge comments are the only way. Rebasing is even worse than squashing. Oh, what? Oh, you want specifically merge comment? Okay, fine, fair enough. Sir, do you know math? I know a bit of math, yeah. It's like asking someone their weight. So we make procedural generated games with algorithms or what? No, we are working on a book or an online education resource known as the Algorithm Archive. So if you just go to algorithmarchive.org, it's basically a way for you to learn about algorithms. The ideas we provide, for example, we go to Thomas algorithm, we provide a description of what the algorithm is and how it works, followed by example code. In a lot of cases, like Gaussian elimination, which I think is one of the better written articles in the algorithm archive, we kind of merge the code and the text, and you can switch between these whenever you want. So I quite like it. It's really nice. And the community basically puts a whole bunch of different implementations into the algorithm archive. So it's kind of my job usually to write the chapter, and it's everyone else's job to usually write and review the code. But we're a bit behind, so I'm doing a lot of pull request merging and stuff like that. So I think this can count as my pull request for the day. But let me see if there's more that we can look at that we can do really quickly. And if not, we'll just kind of go from there. Let's see. So make a procedural generated game with algorithms. What? This has actually nothing to do with games. Just for the record, this stream has nothing to do with games, except for the fact that sometimes I talk about Guild Wars a bit. Like, very little else to do with games. Doctorate students in my country get paid for 20 hours of work a week, so it's pretty much half a postdoc. Yeah, that's actually kind of similar to what we get. What was that? Get the entire website? Was there some weird noise in the stream for someone else? I hope there wasn't a weird noise. If you heard something weird, let me know, because I might have to, do something. I don't know what. But yeah, here's the link to the algorithm archive. It's just algorithm-archive.org. Do you even know JavaScript? I do not know JavaScript very well. Sorry about that. We're actually using Python now. Have you read the book on algorithms to live by? I don't think I've read that one, if that's the book's name. I think the noise is just my headphones cable, so on my end. Okay, cool enough. He taught JavaScript to Africans? Wait, who taught JavaScript to Africans? I think I caught up on chat. I'm not sure if there's more to catch up on, but I think I'm caught up. So I'm going to go ahead and keep working. If I missed your comment and you had said something really cool, feel free to repeat it. I think, let's take a look at the pull request one more time, see if there's anything quick that we can just kind of comment on. Oh, this we're not updating, because I think that's probably fine as it is. Euclidean algorithm in Vim language. Vim language. How do you run this? Like, how do you run Vim language? JavaScript is weird. What about you just listen and figure out what the stream's about? It's fine. Probably in Vim, right? But like, okay, what is Vim language? Vim language. How do I use VimL? Actually, I'm just gonna ask. I'm gonna be like, hey, this is super interesting. I want to review it, but I have absolutely no idea how. Like, how do I? There's nothing in the conversation. So, I don't know what to do. In Vim, yes, run a command at the bottom. Is the language used in the vimrc and stuff? I guess. Hey Gathros, how are you? I hope you're having a wonderful day. Yeah, let's try to review this one. So what are we gonna do? So I know nothing about Vim, so I'm just gonna, you guys are gonna have to help me here. So we are gonna go and we're gonna run git status here, git checkout. I guess we're gonna do git squash or git stash, and then we'll do git checkout master. Oh, that's not how you spell master. Let's try that one again. Git status, git branch, git branch -d, and we're gonna remove the most recent guy, which was, oh, where'd that, here it is, this one. So we're just gonna remove that branch. Let's pull this branch in. So let's see, what do we have here? It is gonna be view command line instructions. Let's grab this guy. Oop, just grab this guy. Oh no, try it again. There we go. That should work. So we'll grab that, enter. So we should have it available now. Yep. Okay. And now I'm just gonna do git book serve, just to make sure it looks fine on the website. And then after that, we'll go from there. Delphi1024 and also AAU96, thank you so much for following, guys. Really appreciate it. So this is for the Euclidean algorithm. I'm gonna check the Euclidean algorithm out, and we'll see what it looks like. And then we'll try to figure out how to get this language to work. I'm gonna need some help from the chat, because I don't know how to use Vim language. So if somebody else does, I'm not saying they do, but if somebody else does, that would be super helpful. A computational geometry Euclidean algorithm here. We want to change this to VimL. There we go. It looks like it fits just fine. Yep. Good. Good. Fine. So it fits fine in the algorithm archive. Is there going to be a Vim language style guide? Let me catch up on chat here. Chat, can someone copy and paste the link to the algorithm archive again? I lost the chat. Lolly, it is... Oh, anyway, Amaros got it. How's the great rewrite? We're slowly getting there. It's slow, but we're getting there. I see Verlet integration. I had a Verlet as a professor of epistemology when I was undergrad. Oh, interesting. I don't know how that's related, but yeah. Let's see, Vim script. Cool. Thanks, Funny Flywheel. Let's take a look here. And again, I am going to look for a Vim language style guide. I would be surprised if it exists. But I'm going to look a Vim script style guide. This is a casual version of the Vim script style guide. Regular expressions. Oh no. Oh no. Okay, so how do you run it? So one notable exception that is Vim's counterfeit file. Vim script files are stored as plain text similarly to other code. The file name extension is usually .vim. So how do we run it? Hey Daily Sid, how are you? Let's see, 6-star, thank you so much for following. Let's see, give us hi, hopefully the stream's not almost over. I'm terribly late. Yeah, so we've still got quite a few more hours, like we have like almost 3 more hours in stream, I think. I'm going to be ending at 6 o'clock p.m. Eastern time, and it is almost 4 o'clock p.m. Eastern time. So we have, what, 2 hours and, at least 2 hours and 15 minutes left. So plenty of time. We just got started on the algorithm archive stuff. What's that tree in the upper right corner of the screen? Tree. I don't know what tree you're talking about. I'm really sorry about that. So the archive will contain Python and VimL implementations of Monte Carlo. How will that work? The following tree. Wait, what? Oh, that tree. Yeah, so that's just a Huffman tree. So a while ago we made a, so that tree right there was from Huffman encoding. Yes, that's what it was. It was just a Huffman tree. We just made a visualization for it, and we're using that visualization for follow notifications. It would be cool if we could like encode the person's name in a Huffman tree, but that's not what we did. I think you need Vim to run Vim. I have Vim. I definitely have Vim. That's not the issue. CD projects, algorithm archive, ls here, cd into content, and we're going to look for Euclidean algorithm, and then code, and should be Vim ls here. So I have Vim. How do I run this? So I'm going to open up Vim. How do I run a Vim script? That's my question. I'm sorry, guys. I'm an idiot. Just pretend I'm 5 and explain to a 5-year-old. Okay. Maybe a 5-year-old wouldn't know Vim. Explain to a 16-year-old. Oh, no, because then the description is going to be all about, like, Guild Wars or something. Explain to someone who just got a PhD how to use a Vim script. Have you guys heard of Wolfram's physics project? Yep, we've talked about it just recently. Watching his streams. That is not true. It's always pre-installed. Manjaro had VI, but not Vim. Yeah, so that's what also Arch had as well. Hello, what is going on? Right now we are reviewing code submitted to the algorithm archive for the Euclidean algorithm, which is just a way to find the greatest common divisor, written in Vim. So that's what we're doing. So for the guy who has the PhD, it's easy. RTFM. Oh, come on. Fine. Vim script. How do you run it? Running a Vim script. I set myself up for that one. Buenov, thank you so much for following. Really appreciate it. Sorry, I don't know how to pronounce your name. Let's see. Have you heard of the binary GCD algorithm? Yeah, so there are so many algorithms that are not in the algorithm archive. We'll slowly but surely get there. I understood 0, but let's keep watching. Well, that's okay. Thanks for being here. We'll do some stuff that's more visually intuitive in just a second. I want to get this kind of ran, and then we'll do the more visually intuitive stuff after that. This isn't what I was looking for. I'm looking for how do I run running Vim language. Maybe if I Google it, it'll give me some better information. Execute Vim script. There we go. Thanks, Google. You are currently viewing a course logged out. Source file name. Cool. So I just want to do source Euclidean.vim. Okay. That seems fine. Yep, seems to work okay. Going to vi-euclidean.vim. I suppose there is a style guide that we need to consider for this scripting language. So let's take a look and see what we have for a style guide. Oh no. Here's the style guide. Portability. It's hard to get VimScript right. Many commands depend on user settings, but by following these guidelines, you can hope to make your scripts portable. Strings. Prefer single-quoted strings. Okay. Matching strings. Use this, regular expressions, dangerous commands, fragile commands, catching exceptions, messaging. Python, use sparingly. Other languages, use VimScript instead. Avoid using other scripting languages such as Ruby or Lua. I thought this guy was just saying, like, if you have to use Fortran, don't use Fortran, use VimScript. If you have to use CUDA, don't use CUDA, use VimScript. You know? Like, that's what I was expecting. Yeah, I think we got it. Source. Let's see. I'm0. I love your chat. Thanks. Run your VimScript command line. I think this is what I was just looking at, or something similar to this. Let's see. Do you want Algorithm Archive to be a comprehensive resource, which everyone goes to at some point? At some point, we're getting there. It's just very slow because I'm obviously, you know, working on my postdoc and all this other stuff. So eventually we'll get there. Can I get your thoughts on the Wolfram project? I missed it. I find it all really weird. I think everyone finds it really weird. I don't really have a good understanding of. I don't really have a good understanding of most of the things he talks about, and so I can't really say too much about it. I think it's really cool, but that's about as far as I can go. I'm just no different than, like, I mean, I could have said the same thing as an undergraduate, you know? Style guide, looking stylish, you can hope, but why are we going down this rabbit hole? Probably off topic, but JavaScript just broke because of a one-line package, NPM package. I'm sorry. VimScript is the next big language. React is over, VimScript is now. You almost said thesis. I did. I was trying to say, I knew there was a P in my mind. It's like PhD, no. Thesis, no. Postdoc, that's what I'm on. I skimmed through Wolfram's book so little, so it doesn't look that weird to me. Yeah, maybe. Like, I have not skimmed through his book, so I personally cannot say whether it's useful or not, you know? I would love to be able to talk more about it, but you have too much P in your mind? I don't know. I guess you're saying don't have a potty mouth, alright? White space similar to Python, 2 spaces. Me, huh? Yeah. Let me take a look at this VimScript guide again, just to see if there's anything obvious that, where did I put it? Did I put it back here? No? Where did I put the style guide? Did I delete it? No, here it is. Google.github.io. I was not expecting this to be under google.github.io. Let me take a look at this, see if there's anything that I see that's kind of weird. I will say that it's weird that he's using tabs, so 8-space indenting. Let's see what they're saying for indenting. They say nothing for indenting. Okay. Other languages use VimScript instead. Boilerplate uses Maktaba. Plugin layout, functions. And the autoload directly defined with this and abort. Autoloading functions to be loaded on demand, which makes startup time faster and forces function namespacing. Commands, mapping, settings, style, whitespace, similar to Python. There we go. Use 2 spaces for indents. Do not use tabs. Use spaces around operators. Okay, so that's one thing we have to mention. So I guess let's go here and just mention that. As a quick review, this looks good. However, it does not perfectly conform to the VimScript style guide. Oh boy. Somehow, this is exciting. Admittedly, I am not sure if this is the right style guide or not. So if you were following a different guide, let me know. Oh boy, the fact that I have to write this for VimScript is amazing. Also, since VimScript is new, should we ask him? Should we ask him? I'm sorry. The Google Python style guide says 2 spaces instead of PEP 8 4 spaces. Interesting. When in doubt, treat Vim script like Python style. Right. Yeah, so I'm going to say here, and we'll say when in doubt, treat Vim script like Python style. Let's see. This guide said 4 space, 2 space indexing, but 4. Do we really care? Do we really care? That's the question. Nudge Guy 9 and Jump Bright, thanks. Jump Bitter, thanks so much for following. Really appreciate it. Let me catch up on chat. White space similar to Python. Have you seen any derivation? Here's some links to the derivation of known equations in blog post. The Google Python has 2 spaces instead of 4. When in doubt, Vim script style like Python. Maktaba sounds like an Arab word. Arg. You are now that guy? Yeah, I'm definitely that guy. Do you know if a language has a lot of different style guides? Sometimes like C++, that's true. Other times like Python, really there's just PEP 8. I know what to do next. I will expand the functionality of my custom JSON choice element handler to transform a JSON object containing such an element into one where the choice has already been made. Good luck with the D&D script. It looks like it's coming around pretty nicely. I'm that guy. It's Google style guide. It's weird on the edges for Python. So I don't even think about following it when I code in Python. So instead of using string that, unless it's standard JS, right. As a quick review, this looks good. However, it does not conform to the Vim script style guide. When in doubt, treat Vim script like Python. So here's the question: do we actually care? Like, do we genuinely care whether Vim script in the algorithm archive is following any actual style? Like, do we care? Like, should we enforce a style guideline for Vim script? That's my question. And are there other style guidelines for Vim script? That's a good question. Vim script. Why am I caring this much? Does it conform to your style guide? It's fine. It looks fine for me. Vim script guide. Why does Google have Vim script style guide? Word about style guides, mastering Vim. Have there been algorithms done for the algorithm archive using just Turing method? No, there hasn't, but there has been white space, which is pretty amazing. Okay. Banana Boyd, thank you so much for following. Really appreciate it. We're all stylists. Okay, so quick poll. Just quick poll in the chat. Here's the question. Do we care? Okay, 1, yes. 2, no. Do we actually care about this particular PR following the Vim script style guide? That's the question. 3, oh, come on, 2. Most people are 2. Most people don't care. 1.5, 9, 2, 3 halves, 2. See, okay, so everyone's 2. No one cares. I'm the only one that seems to care. So Jamie says 1, I guess. 2. No one cares. Ah, come on. So now I don't know if you guys... Okay, fine. So the answer... So 1 said 1. But if you care, I care. I don't really care that much. Like, probably... Pi? I'll leave it up to them. I'm just gonna say it doesn't perfectly conform to the style guide, but I'm willing to merge it if you're happy with that. So let's see. As a quick review, this looks good. However, it doesn't perfectly conform to the Vim script style guide. Also, if you prefer Vim script, that's fine for me. It's used so little. I don't mind merging it as is. Just let me know. Okay, that's what I'm going to say. I'm going to say technically it doesn't follow the style guide, and we're acknowledging that. But also, if you prefer not to use the style guide for Vim script, that's fine for me. It's used so little, I don't mind merging it as is. I'm just going to say I don't mind. I don't mind merging it as is. Comment. There we go. That's our second PR for the day. We're going to move on to working on fractals, chaos games, and other things. Right at what looks like 4 o'clock. That's great. 2 hours to work on the algorithm archive. Perfectly happy with that. As long as the algorithm archive is consistent, I don't care. I do personally care, but not at the point not at the point to be improve the productivity of other coders. Who's going to run this in VimScript anyway? I just ran it in VimScript. The guy will be like, VimScript style guide? What is this guy on about? On the other hand, a foolish consistency is a hobgoblin of little minds. What? Does it say that? Tell me it says that in the style guideline. I'm going to look for hob. No, it doesn't. I would love it if it said that in the style guide. What did I press? F12? I wouldn't accept obscure fringe languages personally. And then you notice you wrote VimScript. Oh, did I misspell VimScript? Implement, edit, VimScript, VimScript, update comment. Let's see. You work in AI. That's a quote from Emerson. Emacs list is an obscure language. We already have emoji code samples. Well, okay, so the way I see it, as far as obscure languages are concerned, I agree with that statement, right? Because you could say that these obscure languages distract from the overall purpose of the algorithm archive. On the other hand, we have real languages too. We have Java, we have Julia, we have Python, we have C++. We have all the languages most people want to implement, right? So the way I see it is having these obscure languages doesn't actually really subtract from anything because we have the other stuff too. And really, it's kind of like an interesting Easter egg, if anything else, right? The only place that people are actually going to see it affecting their day-to-day browsing is when they go to, I don't know, bubble sort or whatever, and they click on this, there's going to be a lot of languages available. So they have to maybe look for their specific languages. So maybe we could like put all of the important languages on the left and all of the, you know, non-important languages on the right or something. But for now, I think it's okay. If anyone actually cares, write Emacs Lisp. I'd be glad to check it. It can't be that different from Common Lisp. Tacat14, thank you so much for following. Really appreciate it. For the algorithm, yes. Link to the algorithm archive, it's here. I assume that's what you're looking for. Okay. Then I think we are good to go. What is Servois in the Easter algorithm? So Servois is the guy's name, so it should be Servois table. So if we go to Computus, I should have said here. So one of the most important fans of Gauss's work was Servois, who created a calendar based on Gauss's publication, 1800 publication. So because this is an application of Computus, I wanted it to be that you're able to output that table. So that's because that's one thing that we found quite useful. Love that Zadiston made that. It's amazing. I checked Bogosort in the archive and it said that it isn't used in practice. Yeah, I'm sorry. Quite frankly, the sorting and searching needs a lot of help. There's a lot of places in here that need a lot of help. That makes things hard in C. We could consider refactoring the code to make it easier. Let's see. So Python, Julia. On the other hand, you don't have to return the same types, I don't think, in C. So like what we're doing here, what do we have here? We say if Servois equals false, return mod. I guess the moon should be pulled by the sun in that example. Wait, what do we see here? The function outputs a string or number. Right. You can just have it output a number. Yeah, I meant to change that. You're right. We can change that later. Let me do an issue for that actually. I'll create an issue right now so I remember to do this next time. Issues. We'll do a new issue. Computus general issue, I guess. We'll say Computus output inconsistent for we'll say Computus return type inconsistent. Thanks for issues description. For Computus, it is the Computus function can return either a string or a number, depending on whether you are outputting a the table. We'll say Servois table or not. This is hard to do in C. We should change the implementations to all output a number. I'm waiting. I'm watching the chat. instead and format after. That's what I was thinking. It's inconsistent. Let me see. Let me catch up on chat then. Check bogus sort. Personally, if obscure esoteric languages demonstrate a non-trivial way to accomplish the algorithm, I think is a worthy inclusion. So for example, BrainF is worthy of inclusion due to its limited tools, but JSF isn't because it's encoded JavaScript. Yeah, I could see that as well. I mean, it's really close. Vexos, I know I just want to bring this up. You can make one method that does the first part, then one output server-wise number, and next output text. Why? That's Klima. Oops, my bad. So we'll go here. Oh boy. Okay, we'll do feature request. Modification. Oh man. Also, we shouldn't change. Are you sure you're watching? Let's see. We also shouldn't change algorithm archive implementations. If the language supports it, do it. Other languages can do it differently. Yeah, maybe that's what we should do. Really shouldn't. You know, like, I was about to ping you on Discord for that. Oh well, that happens. Let's see, Jay Schules and Henry Quero Charafel, thank you so much for following, really appreciate it. Oh boy. That would have been an amazing update. So what do you guys reckon? I mean, we could change the implementation so they all output numbers. That's not hard to do. That's not hard to do. We could definitely do that. Or we could have it so, you know, different languages output different things. What do you guys reckon? I don't mind either way. Let's just put it to a vote. This 1-2 system seemed to work before. So journal, new page before. Consistency with all languages. And we'll do 1, yes. 2, no. Does this make sense? So, like, do we care that C++ has the same return type as Julia? That's the question. Can you never be consistent with all languages? I clipped it though. 2, but I need more explanation. 2. So 2, we're seeing a lot of 2s. Memesh 1903, 1. It is split, so let's open it up an issue to discuss it. I didn't, okay. Computers, Control X. New issue. Let's just put it here. And there. Let's see. What I mean is that, here, so the computers function can return either a string or a number depending on whether you're outputting a table or not. What would MIT say if you posted that issue? They would know. I mean, they know about my side projects. But I'm going to close these guys just to be safe. They know about my side projects, so they would definitely know. And they'd be like, what an idiot. It must be type consistent. I missed the question again. It must be type consistent. 2.718, return type in a string versus an array, or array versus list. You didn't even explain the 2 options. I thought I did. Do we want all the language implementations to be consistent, was the question. So like, for example, should the C code output the same types? So basically the issue here is that this particular function could return a string or could return a number, which is why you're right, it must be type consistent. What does consistency mean? I think I screwed up here. I think I screwed up here and I should have made the function type consistent. How can the same algorithm output a string or a number? The algorithm calculates the date of Easter, right? So because the algorithm calculates the date of Easter, it returns a number, which would be basically the number of days until, number of days since the date of Easter, right? So in some cases, applications want you to output a number, where they want you to output the number of days from March 22nd to the first Pascal full moon. In other implementations, they want you to output a date, which would be like April 1st, right? So in one case, you output April 1st, which is a date. In other cases, you output a number, which is the number of days since March 22nd. So that's why it can return that. That's why we return it. Akevalish Shay, thank you so much for following. Really appreciate it. So that's impossible anyway. Right, but I mean, the return types should at least be consistent. In other algorithms, we made two functions. If the algorithm outputs a number of days, I'd say it's a number. If getting the date is a separate step, because you can do what you like. A Java implementation will look different from Haskell. I agree. BF doesn't even have the return types. Yeah, okay, so maybe what we need to do is we just need to make this particular implementation type consistent. So like it just returns, so Computus always returns a number. And if you're looking for Servois number, it returns that number. If you're looking for the number of days until Easter, then it returns that number. So it always returns a number. Let's see. I think the algorithm should be absolutely the same. I think in this case, I think I'm caught up. Let's see. I think it should return a string unless the language can't do that, in which case there should be a note on the page of the archive that can't return. Oh, actually, you're right. You're right. I think you're right. I think it should return a string as well. If we look at the code, here, let's go to Easter algorithm, and let's just scroll down to the bottom. And we go to, I'm also going to change this so it's white mode here. If you look at this, we're returning a number here, right? But there's no reason this has to be a number. It could just be a string, and then it's fine. How can the answer to the same problem be a string or a number? It's not answering the same question, right? So this algorithm can do a number of different things, right? So we put a switch in there, and we say, if you're looking to calculate this thing, it outputs a number. If you're looking to calculate this thing, it outputs a string. But we can have it output a string entirely, so it could just have this be a string. I think it should return a string unless the language. The algorithm repository should be useful, and I don't see use cases for brainfuck or whitespace or anything else. It's not interesting per se. Anything else like that, I mean. I understand and somewhat agree with that sentiment. However, personally, I think that these languages sometimes are useful. And honestly, like a lot of times for these languages, people want to learn them. I've wanted to learn whitespace for a long time, but it's hard to find a repository where you can actually look at these algorithms and you can learn the algorithm, and then you can be like, okay, I see it in whitespace. Besides, these esoteric languages will only be used in simple algorithms like Euclidean algorithm, or not even bubble sort. Maybe bubble sort, but it's not going to be used in actual algorithms that are used in practice, right? Because it's just too hard to have an esoteric language for that. So it's only there for very small, for very like limited algorithms, and also it's not, in my opinion, like it gets people excited. So why not, you know? Let's see. Every page needs to be useful and educational. That would exclude much stuff without the real world usage. Yeah, also it is the arcane algorithm archive. So, you know, the algorithm archive should give implementations in a language that you understand. And if the language's type system is different to C's, that means that the implementation should be different. Because if the implementation was the same, then that enforcement would make the implementation very unorthodox in some languages. Right. I don't think we should say no, but we will not encourage people to write it. Yeah, I think that's my philosophy about this as well. Let me see if did I do this right? So we have computus.a servois equals 2, collect, right. So the way this is done is we create a set of dates, and then so we basically create the servois table for 2020 to 2030. So it's just a set of 10. And again, it doesn't matter if this is a string or a number. So we could just have this output a string. And if we have it output a string, that solves all the issues. And there's kind of no reason not to do that. So I think implementations should take advantage of the language features, but the interface needs to be as uniform as possible. Simulus, I think that some people are interpreting the question as should the return value represent answers to the same question, and some people are interpreting it as should the return values be bit for bit identical. Maybe. You can represent both numbers and dates as a string, but not easily represent a date as a number. Right. So that's why I think we should just change it to strings. And I think that solves the issue. We can actually open up a PR right now that just changes all this code to be strings. It should be relatively straightforward to do. Why not have two functions? We could do two functions as well. It's just that, yeah, we could do that. In this case, I agree it should be consistent, but not in general. We don't want arguments over what languages are useful, or else people will use that to debate things like whether Lisp and Java are useful. Right. I mean, obviously, people are not arguing that brainfuck is useful, right? People are arguing that there could be some information to gain from implementing this in brainfuck that you wouldn't see in another language. That's the argument, and I think there is some merit to that argument. So I guess Java is useful. Sometimes. There are no useful languages other than Julia. Oh boy. Not sure where the argument is. Anyway, so why don't we just do that? Why don't we just create a PR changing all of the return types of currently existing Computus algorithms to be strings? That's what we do. It'll take 2 seconds to do. It's super easy. Let's just get it done. Git checkout master git poll up organization master git checkout -b string Computus. Okay, let's go over here, cd back a couple of directories, cd into Computus, ls here, and we're going to cd into code. Cd into code, cd into Julia, and let's modify this one, gausseaster.jl, and all we're going to do is return string and then we'll run that really quick. Okay, seems fine to me. Year, Servois number, Easter is off. Okay, that's interesting. Okay, how do we, I guess we need to remove a tab? I guess I put one too many tabs in there. Too many tabs. What? Okay, well, it is what it is. Fine, fair enough. Let me catch up on chat. Here we go. The discussion of what's useful and what's not. Java is number 2 most useful language, just behind JavaScript. Maybe. Java's number 1 most used language, then Python, then JavaScript. Is it? I've never seen Java in the wild. Like, every time people bring Java up in chat, it's like, I don't know where it's coming from because I've never seen it, you know? I'm not sure you could really split the Computus function without having duplicate code, so the return type change is more elegant, I think. I mean, I'm a real person and contributor who would argue brainfuck is useful, so this standard probably won't work. Is the table really needed? I guess this algorithm comes from the Holy Bible. No, it doesn't. It actually comes from Gauss from the 1800s. We had a huge, like, literally 2 weeks worth of just talking about Easter. So we talked about this a while. So it's a bit newer than the Bible. So the table does not, your editor has unorthodox tab width. So the table does not align with other systems. If only there was a Julia library for table formatting. There probably is. At least all the others have tried. Tons of companies teaching and using JavaScript, Android, Java. Your SIM card runs Java. I'm just gonna, let's just see what happens. So, oh, I don't know what I was doing. cd back directory, ls here, cd into Python, ls, and let's go into vi gauss easter.py, and you modify it with str. So we're just gonna return str of this. Let's run Python gausseaster.py. Yeah, I don't know what to do about the tab thing, honestly. Printf year, tab Computus. I want 2 tabs here. I don't know. We'll see. I think 2 tabs should do it probably. cd crystal. Now here's the one I don't know how to do. How do you run crystal? If you remove the 2 tabs, it will look bad on every other machine other than yours. Right. So that's the problem. I did those in my PR. Can anyone else confirm how many tabs they need for the table to line up? Yeah, we'll figure that out in just a second. How about we talk about that on the PR as well? How do I run crystal code? How do we run crystal code? That's not what I was looking for. G there. And let's see what we got. How to run crystal code. That's also not what I'm looking for. Apparently cookie run. Programming language? Crystal run. So do I have Crystal installed? Crystal. I do not. Yay-s Crystal. Can I just do yay-s Crystal? Sure, let's go. And we'll just do Crystal. We're gonna look in gausseaster.cr. Cool. Okay. So let's go into vi gausseaster.cr. You're right. I think you're right. It just needed 2 tabs. I think 2 is the correct number. I don't know why I needed 4 last time. How do we turn something into a string? You do it by .toString. So if we return this, and I put this in parentheses, and I change this to .toString. And then we try it one more time. That should work. Okay, nice. That looks good. Wait. With only 2, it breaks on other systems. Oh. So you're saying pretty much everyone else needs 4 tabs. But a tab is 8 spaces, right? So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That looks like 2 tabs. Tab is 4. Oh, tab is 4. Oh. Okay. Does anyone else know how many tabs they need for the table to line up? Okay, let me open it up in another terminal because I bet that's it. So let's open it up in what do I have? Terminator? Okay. I don't have Terminator. Sakura? Oh, you've gone downhill, Sakura. Okay, so we're gonna cd into projects, algorithm archive, content, Computus. I'm missing some of chat. I'm sorry about that. Computus, code, Julia, and then we'll run Julia. gausseaster.jl. That lines up. Tabs are usually 8 spaces, I thought. Try crypt tab. Yep, no crystal. Oh. Let's see. No, I typed in cry tab and it brought up cry p. Does anyone else know how many spaces? 4 spaces in XFCE terminal. We should just use space. But how do you know the number of spaces you need is the question. 8 is functionally... Yeah, that's what I thought. I thought 8 was functionally the default. In terminals, tabs are always 8. Not mine. My tab is 2. 8 is huge. Yeah. I always decide on fresh Ubuntu. Let's see. Does anyone else know how many tabs they need for the table to look up? Only 2 or 4. 8 is weird. 8 is normal. Like 8 is... I've never seen 4. You have to auto set 4. Like... That's why I'm kind of confused here. Despite 5 characters being the typical paragraph indentation for typewriters at the time, the horizontal tab space of 8 evolved because, as a power of 2, it was easier to calculate. With the limited digital electronics available, using this size tab to indent code results in a lot of white space to the left. So most text editors for code, such as IDEs, allow the size of the tab to be changed, and some, in particular on Windows, default to 4 instead of 8. Yeah, I've only seen 8. I'm surprised that it's 4. So let's see. 8 is functionally the default for general use. Again, I'm super surprised you guys have 4. Like, I'm genuinely surprised. Because I've only ever seen 8. Ubuntu defaults to 4. Alacrity recently moved the functionality to change tab width because values for other than 8 just cause issues because every terminal program assumes 8. Have you ever once in your life used Windows? Not since I was like 14. Like I haven't used Windows in a very long time. Okay, so I guess if Ubuntu does that, I don't know then. You're right. Maybe this table is just making things too complicated. Maybe what we should do is just have Servois table, and then we have Easter as a separate column. So like, you know what I'm saying? So we just have Easter as one column, and then the year and Servois number as a separate column. You know, like, okay. I don't have it in my config, but it's 4 by default. I just got error message. Yeah, it's probably, I mean, it's probably not in your personal config. It's probably in some configuration file set by Ubuntu, you know? I just got an error message that because I had it in my config. All my terminal emulators have 4. I'm just super surprised. Like, I'm really surprised by that. But I mean, yeah, fine. I'm not saying you're wrong. I'm just surprised. What if you switch the Easter and Servois number? Oh, that would work. Yeah, that would work. Then it's just 1 tab per, and it's probably fine. So let's change this. If we do, put it here, and then we're just going to do Easter date there, and then tab Servois number, and then just DT, and we run Crystal Gauss Easter. Okay. Okay. Git diff Gauss Easter.cr. I screwed it up. Really screwed it up. Can I use spaces and it'll work with all terminals on all machines, provided they use monospace font? Right, but the issue is we don't know the number of spaces. Like that's difficult to calculate. So I don't know. How do we go from fractals to spaces? We're gonna go. We still haven't gotten to fractals yet. The whole situation is ripe for falsehoods programs believe about text entry. Gregorian, not Julian Easter. It is a Gregorian Easter. Orthodox Easter can be in May, so it's really not the same. Yeah, so the Orthodox Easter is half the time 1 week after the Gregorian Easter. So should just show a data frame. I guess we could, but then we have to construct the data frame, which is kind of more annoying. Let's see. What did I do wrong here? It should be a. Right. Am I missing a tab? Maybe. Oh. Here it is. No, I'm missing something else. Unknown token T. I see what I did. I need a closed brackets here. That should do. Oh boy. That's not gonna work, is it? Darn. How about I just put a PR up for outputting. Yeah, I just put a PR up for outputting all strings, and then we worry about this later. Because at this point, I'd like to get onto other stuff on today's stream. So let's just put this down. Again, I would be super surprised. I am super surprised to hear that 4 is ever used for a number of tabs. So I'm just like I'm blown away that that's something that people like. You know what I'm saying? Like 4 spaces for a tab seems like sacrilegious to me. Falsehood. No, tabs are definitely okay. So I don't. So we'd have to calculate the correct number of spaces, which would mean I guess we could. I guess we would know that number of spaces. So it would be A. Let's do this in Julia because I know Julia. CD backer directory, CD into Julia. VI code. Sorry, GaussEaster.jl. We do know the number of spaces, actually, now that I think about it. So instead of tab, we'll do concatenate this with. Oh no, this should be a number of spaces. So it's going to be year. Oh no, we don't, because there could be a different number of. No, we definitely need Servois number, no doubt. If you read the chapter, I think you'd agree. Actually shaken up. I'm not shaken up. I don't know. I'm just like I'm just surprised. Like I'm genuinely astounded by this, you know? Here's a GitHub issue for the removal of tab spaces. It is 8 spaces. Do we even need Servois number? Just print it twice. with twice, once the 2 tabs and once with the 4 tabs. That's how you do it. Okay, let's... You're right, that's not the best way to... that's not the best way to output this. Yeah, so that was what I was gonna do, Gathros. What we could have done is we could have had them both output numbers instead of strings, and if they both output numbers instead of strings, then you could take one of them, which would be... So, okay, I mean, the issue is the following, right? Like, so we have March 22nd, right? We have 2 values here. We have D, and then we have D plus E. D is the days to the full moon. D plus E is the days until Easter, right? So for Savraw's table, you only need D. For Easter, you need D plus E. But we could have Computus return the values of D and D plus E, and then format it later. Like, we could then do the final step, which would be this step in here. We could do that step at the end. It's just, the thing is, this right here, this D plus E minus 9, this 22 plus D plus E, is technically part of the algorithm, not kind of, like, this wouldn't be something that you would naturally do when just formatting it. So I wanted to put that in Computus, which is why I put it here. Just naturally, that's where I wanted to put it. So that's why it's there. Really decent. Thanks so much for following. Really appreciate it. Sorry that I missed that a few minutes ago, or a minute ago or something. So that's why it's there. I'm just gonna put a PR up, and then we can bicker about it on the PR. I think that's probably the best way to do it, because I think at this point, we could keep talking about the difference of tab spaces, but it's clear that we need a better way to output this. So let's just go back a directory, get status, let's add what we have in, and then we'll just say we want to output strings now as a PR, and then we figure out how we want to output the table at the end, and we modify the code to do that. That's what I say. Git add dot git commit dash m modifying modifying Gauss's Easter algorithm to output strings. Cool. Okay, so we'll just am I on the right branch? Yeah. So we'll just do this, and then we'll talk about it. We'll talk about it on the PR. I think that's probably the best way to do it. So new issue. I'm on the algorithm archive this time, which is good. I need to push this. So git push. We'll do origin. Why not? String Computus. Okay. Right. Okay. And now we'll just compare and pull request. And in here we'll say there is no reason for the return types to be different if you are returning the number needed for Servois table. I guess that table. As a note, we probably need a better way. Let's see, better way of displaying the table at the end, because tab spacing is inconsistent on different terminal emulators. Okay, let's go ahead and create that pull request, and we'll just bicker about it there. I think that's probably the best way to do it. I'm sorry, I know that's like super like defeatist in a way, but I forgot to assign labels. This will be a let's see, Gitbook, Hacktoberfest, none of those are true. Problem question, small changes, implementation edit. There we go. That should be fine. We have a meta chapter for table formatting. If there's a table formatting algorithm, I'm more than happy to put that into the algorithm archive. Let's see, what do we have here? Table formatting algorithm. There probably is, right? You've got to Table format, tables, table content. Nope. Let's see. Formatting algorithms of tables. Formatting algorithms of tables. This paper provides a description of the formatting algorithm of tables that authors have developed. This algorithm is an important component of the so-called Tafelmusik environment. Provides the user with an environment to deal with various aspects of tables, logical, maybe. This is a maybe. It's a weird one. This is a weird one. Also 1997, so it's not so arcane, but it's a thing. Let me catch up. Python tabulate. I'll catch up on chat right now. Sorry about that. I'm a bit behind. Let's see. Python question is for key dictionary. Kosher, I think is fine. Yeah. You switched up the I and O. Did I? Did I do that in the chapter? Okay, I don't think I did it in the chapter. No, I didn't do it in the chapter. I think that's okay. Let's see. I've decided to use .keys to explicit. Might be relevant, mostly used for key. You had the C++ link on that results page. I had the C++ link on the results page. What do you mean? Arcane doesn't mean old. We can still write it. Yeah, that's true. Or I wrote a bunch of terminal table stuff at the last AI job. Interesting. You think we're simulating? For key value D. Might be able to steal it. 1 second. Search results. Okay. Yeah. Python tabulate. Okay, we can talk about this later. I really need to start working on the iterative function system stuff. So I think we need to move on to that for a bit. I'm sorry, I know we could talk for hours on how to properly formulate and create tables with tabs and spaces, and it's an incredibly interesting conversation. Surprisingly interesting. But I think we should move on to the next topic, which will be creating fractals, which sounds a bit more interesting, but I don't know. I have no idea what people are interested here on Twitch. So let's go. Iter items is not relevant anymore in Python 3. So this might not be relevant. Anyway, let's move on. So we did our algorithm archive stuff for the day. Took a bit longer, but that's, I guess, anticipated at this point. So cd into projects, simuleos. We're doing the same thing over here. cd projects, simuleos. And we'll go into fractal as well. Here, cd fractal. Okay. I was hoping this channel was live now. Hey, how are you, Barrett G1? I hope you're doing okay. But yeah, we're live. So I'm going to be trying to do somewhat longer streams. So I want to do a 4-hour stream pretty much every day, with exception of Monday, where a stream is iffy because I have a meeting during my normal stream time. And what's the other day? Thursday, in which it will just be a 2-hour stream. But my stream time will normally be from 4 to 6, and then I will either do from 2 to 6. Okay, so my stream time is going to be from 4 to 6. That's my normal time from now on. But I'm going to add 2 hours on weekdays and subtract 2 hours on weekends. So I'm going to stream a bit earlier on weekends and a bit later on weekdays, and I think that's what I'll do. It is super hot in this room, and I don't have any air conditioning in this room, and it's in the middle of Alabama, and it's 80-something degrees outside. So anyway, I have a plebby question about the cost of functions in neural networks. Can anyone explain why cost function matters? If data is random, neural firing is random, why changing the cost function for the local minimum makes the accuracy of the model better? I could try my hand at that question, but I'm not an expert in this field, so I don't know if I can give you an appropriate answer. The only reason I know cost functions and stuff is because I know like minimization algorithms and stuff like that. But it's not very, no, it's a good question. Like, I have a PhD and I don't know the answer offhand. My guess would be that the reason, cost functions matter is because cost functions are usually what you're evaluating, right? So like, there's a 3 blue 1 brown. Yeah, check out the video then if there's a 3 blue 1 brown video about it. Okay, so let's talk about fractals. We're gonna move up. We're gonna do journal, new page before, and let's go. So we're gonna create 3 points in space: A, B, and C. A, B, and C. Okay. And we're going to create three functions. Function 1 is going to be equal to p plus a over 2. Let's try that one again. P plus a over 2. Function 2 is going to be equal to p plus b over 2. And function 3 is going to be equal to p plus c over 2. Now, all of these guys return basically the midpoint to that function. So for example, if we have a point here, function 1 will bring it closer to a, function 2 will bring it closer to b, and function 3 will bring it closer to c. Now, what we're interested in doing today is something slightly different than what we were interested in doing yesterday. So yesterday we were talking about the Hutchinson operator and how we iterate through space and all that kind of stuff. Today, we're going to talk about something called a chaos game. In this case, what we do is we take a random point, it doesn't matter where the point is, and we allow it to select from any of these random functions, right? So it might move halfway towards A, and then halfway towards B, and then halfway towards C, and then halfway towards A again, or something like that. And then halfway towards, I don't know, B, which should be maybe here or something like that. And the point is, at some point, as this point's moving around, it will eventually land on the Sierpinski triangle. Okay? So let's say this point, for example, let's say that point was slightly off, and that point landed on the Sierpinski triangle. So that point landed here on the Sierpinski triangle. From that point, any other movement after it's on the Sierpinski triangle, any other movement, as long as it's following one of these functions in here, will be along the Sierpinski triangle. So it can move halfway towards A, and that'll put you maybe, I'm going to say here, which is going to be along this triangle here, right? So it's now a part of the Sierpinski triangle. If you move halfway towards A again, it's going to be here, which will be a part over here, right? So the point is, no matter how many times you move in space, after you're on the Sierpinski triangle, as long as you're moving along this function system, you're always going to remain on that triangle. And so what we're going to work on is a visualization of this fact. And we'll show you what we did yesterday. So let's go and do G++, and we'll talk about what we need to do to update it today. Let me catch up on chat here. Barrett1G, let's see. Random doesn't mean man without trends. Doesn't mean without trends. PhD does not mean you know a lot of stuff. That's true as well. But, you know, when people come in and they say, I'm an idiot, I'm like, I'm a PhD. So when people come in and they say, I'm sorry, I'm an idiot, I'm like, well, I have a PhD and I am also an idiot. So, like, you know what I'm saying? Let's see. Literally came from 3 Blue and Brown and it's still beyond me. It sort of seems like witchcraft, like it works because it does. In fact, PhD means you'll know less stuff than other folks. I don't know if that's true. I think PhDs might be more willing to admit when they're wrong or they don't know about something, but I don't think they know less stuff. I think, in fact, they probably know more stuff. Welsh Lab's video about neural networks. Yeah, Welsh Labs is pretty good. I'll check out those. Thanks, Embers. James does happen to know a lot of stuff, including the fact that I have a PhD is more efficient than I know a lot of stuff, and convincing people he does, in fact, know a lot of stuff. Yeah, that's actually kind of why I said that. I think you have a misunderstanding more in randomness than any specific neural network. If you don't value PhDs, that's fine. Instead, you may evaluate his intelligence by observing him and how he solves problems. Well, thanks for that. I'll take this as a compliment. That might be the case. For example, a person selected at random has random height, but there's still expectations about what values that height can take. Germany actually has 2 different words for actual randomness and statistical randomness. Interesting. Here's another playlist. Yeah, sorry for off-tracking the off-topic. The topic. Fair enough. I'll look this up myself. Thanks for the leads. Let's see. It's okay. Don't worry about going off topic. I mean, if you worked on a single topic during a few years, you're not going to have more general knowledge than people who were solving diverse problems. Right, but I would also argue that in general, PhDs, you know, because they're solving a specific problem, does not mean they only have a specific subset of knowledge. You need some general knowledge to build from to solve that problem, too. So just because a problem's specific doesn't mean you don't have a general amount of knowledge, right? Like, I have very specific knowledge on quantum systems that I probably will never use again. But I also have somewhat general knowledge on different algorithms and methods used for various solutions, you know? So I feel like having specific knowledge and general knowledge are not mutually exclusive, is what I'm trying to say. The mark of an expert is that he knows when he does not know. Yeah, I think that's true. English has stochastic, but I mean that no one uses that word. People use that word in academia all the time. The real idiots are people who barge in like, I'm smarter than you. Yeah, that's also true. Or rather predictably and unpredictable randomness, I guess. Okay, so let's take a look at this visualization. Should be here. There. And we're just going to npv temp video.mp4. And here's the visualization we have. So the first thing you see is the Sierpinski triangle being generated, right? This is the same animation you saw before. Then we have specific dots showing all of the random movements to, let's do all of the random movements until it's on the Sierpinski triangle. So we started with the point here in the center, moves here, and then up here, and then up here. It just kind of moves around, right? And so we drew a line. Unfortunately, these lines are supposed to stay, but they are not staying. And I don't know how to make them stay. So I'm gonna have to like do some GathVL magic stuff. Luckily, the developer of GathVL is here, so maybe we can get this done. So let's see what we can do. So we're gonna go into VI. We're gonna go into VI Sierpinski .cpp. What algorithm we just described? Wait, what is the algorithm you just described useful for? It's useful for, you know, generating fractal images, but also is used a lot in like just random areas, you know, like fractal geometry is used for turbulence modeling. It's used for fingerprint recognition, weird stuff. It's just used all over the place for weird things. I spend so much time learning a large number of topics, which is why I'm learning CS. Yeah. Stoichiometric is also a good word, which I feel like I know, but I don't know. Okay, so let's go down to the function we're looking at, which is Sierpinski chaos here. Okay. In particular, what I'm doing is I have a line, which we call arrow. Really decent. Thanks for saying it's a really cool stream. Hey, Uncle Bill, how are you? Hey, Flask, how are you? Right. So what are we doing here? The drawing of the Sierpinski triangle right now is not so much of a problem. It is being drawn, I think, appropriately. Now I'm going to change it so it actually goes from blue to red, not red to blue. So I'm just going to do this. Oh, I'm sorry. I wanted to go from red to blue, not blue to red. My bad. And we're going to delete these lines in here. And that's all I want to do for that. I think that'll compile, no problem. Okay, you'll see what I did in just a second. I'm sorry that wasn't very, very clear. Okay, so now let's talk about this line thing. So after we have the Sierpinski triangle drawn, then what I'm doing is I'm drawing this animation that I just saw. The point is going to start from here, and it's just going to move around wherever it decides to move around until eventually, again, it's on the Sierpinski triangle, right? So that's what I'm trying to draw, just a series of lines until the point is on a triangle. Something like that. Known as OChem. That's what I knew it was a chemistry term, but I don't remember what the chemistry term means. I feel like you learn about stoichiometry in high school chemistry and Gen Chem, but once you hit OChem, it goes out the window. I need to learn. I forgot chemistry. You guys seem to like Greek words. Greek is the language of mathematics, so yeah. The answer is yeah. I just hit my microphone. Sorry about that. Balancing reactions. All right. Thanks for that. Okay, so let's see. First of all, we have a ball. All of these balls are being generated at the right spot. The problem comes with this arrow generation, drawing the line from point to point. So here we have auto arrow is equal std make shared line color location location. So we have a line that's being generated at the same location, so it's just a dot in space. Okay? So now what we have is arrow add animator, vector animator, and we give it the frames that we're drawing on, which will be 60 plus I times 35 plus 4 floor of n over bin size minus 20. Now this, and this should be the same. So I'm trying to figure out why. No, mathematicians like Greek letters. The physicists just use the same language and tools for math. Yeah, that's true as well. That's probably correct. I started to learn Greek recently, exactly due to this reason. I want to know where our words come from and what they actually supposed to mean. Oh yeah, that's fair. Like there's a lot of weird words that are used in mathematics, chemistry, physics, all that kind of stuff. I'm also considering Latin. I don't know if you actually need an understanding of these languages in order to like use the languages for your purposes, but I will say that, you know, props to you for learning them, you know. I've always wanted to learn more languages, but I'm still stuck trying to learn Japanese. I've been trying to learn Japanese for years. Okay, so 60 plus I times 35. What is this supposed to mean? So what this should mean is that each line drawing should take 30 seconds. So what I'm gonna do is I'm gonna take these 3 lines, yank through yank, and I'm gonna paste them up here, and I'm gonna comment these guys out. Oh. And then I'm gonna just try some different line drawing techniques to see if I can get this to work out the way I want it to. So we'll say 60 plus I times 35. So let's just do dt here and dt there. So what is this going to do? So if we're on I equals 0, then the frames are going to be drawing from 60 to 90. If we're on I equals 1, it's going to be drawing on frames 105 to 125. Oh, sorry, 95 to 125. Then after that, it's going to be drawing from frames. Yeah, this seems right. Right, this. Let's go over here. Let's run g++. Okay, and let's run /Sierpinski, and let's see what happens this time. Threes, thank you so much for following. Really appreciate it. Let's see. Good luck with principal parts. It is actually extremely important in OChem for elucidating mechanisms. Oh, interesting. I didn't realize you'd actually need it for anything. Another fun stats word is heteroscedicity. It's much harder than Russian or German. Latin is by far the easiest language to learn. It has a lot of rules, but almost no exceptions to those. I wouldn't say easiest. There's Ciceronian Latin. It's very easy. It's very much the easiest language I know. Also be wary because there's two Latins, Ancient Latin, Modern Catholic Latin, and only Ancient Latin matters. Oh, interesting. I didn't realize that. Modern Latin has a lot of new words that make no sense. I've seen that spelled with a K. Okay, so let's take a look at this visualization. Yeah, let's just loop it. We should see a line being drawn. Right. So I want the lines to stay there, not move around. That's my issue. The lines are moving when I don't feel like they should be moving. So I'm going to just put this in the upper left-hand corner while we work on it and try to figure it out. So I'm not sure why it's doing that, but that's what we need to figure out. Put that there. Great. Okay, so why is that line moving? Oh, Barrett1G, thank you so much for the subscription. Really appreciate it. I'll put a SimulCow in chat for that. Really appreciate it. Thanks so much for the support. That's why I don't think it's relevant, even if you think it adds nothing to your life. Wait, what? For Latin, you mean? Oh, I had Latin schools. Do you know? Oh, I missed a lot of chat. I'm so sorry. Modern Latin has a lot of new words that make no sense. You know how we were able to access the ancient Greek math knowledge? Because we had continuous tradition of learning Greek and Latin, which we discontinued recently. I see what you're saying. You're saying that, yeah, okay, I can understand. Yeah. Okay. So, why is this line moving around? It could be because our arrow here, we're using the same arrow all over again, right? And we're just adding that arrow again and again and again. So that could be an issue because that just means the arrow is being animated. And then after it's being animated, after being animated once, for some reason the start and end are moving. So like that's the thing I don't understand. Why is it like lasering about? You know, it's like choo 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 choo. It's like you know what I mean when I say lasering, right? Like it's just moving all about like that. Why is it doing that? Well, let's just pause it somewhere. Okay, here, for example. Well, let's let it go again. So, I think I know. I think my end location and my start location messed up. So arrow.end should go from location to previous location. What? That seems weird. So let's go here to g++ /Sierpinski, and let's see what that does. I like that effect. I mean, it's a cool effect, but it's also not what I wanted to show. Let's see. By the way, English is like the new Greek and Latin, so I believe we should treat it responsibly as well. I think you're right. I think like most people know English for their particular, like most technical fields use English as their language of discussion. Whether that's what should happen or not, that's not the discussion we're having. That is simply how it is. In most scientific fields, English is the language that is being used. Funny story about that, specifically Russian. When I took Latin 202 my freshman year, my professor's native language was Russian, so she was very adamant on getting declension, and conjugate right. Russian has a very similar system. And for German, for some reason, the German language really grinds her gears, even after years of study. Oh, I'm sorry. So what happens here? Oh, Well, okay, we have the lines staying, but they're being drawn from the wrong location. Also, it looked really weird there at the end. Oh, no, it is correct, but we're drawing from the wrong location. And that's because what we want this to do is we want previous location here. And we want location here. But we want to initialize it at the previous location. So I think that's my issue. Write that, go over here, run Sierpinski, and I am now going to uncomment these lines down here. And we're going to do that. So I think this is closer to what I want. And then we have one more thing we have to fix, which is a bit harder. German is a hard language, but still easy compared to related languages. English is the new lingua franca. Almost all chemistry before 1910 was done in German. It was required for reading old papers. Yeah, there's a lot of papers that I've had to read that are in weird languages as well. And by read, I mean just skim and look at math and pictures, because that's all we could do. There was one time, oh boy, this was so much fun. There was one time, my boss at OIST, right? So OIST is a 100% English-speaking institution, but it's in the middle of Japan, right? So, well, it's in an island in Japan. So what we had to do is we had to, I just ran it again on accident. So what we had to do is we had to interface with the rest of the Japanese academic system, but that was hard. So we went to a conference where pretty much everyone was only speaking Japanese, and we presented our talks in English, right? And so we would see all these talks in Japanese that none of us could understand, and we would just raise our hand and be like, hey, I've got a question on slide this. Does that mean that? This? And like clearly people would answer in English, because they knew English, but like they weren't giving their talks in English, right? They were giving their talks in Japanese. And even one of the students in our lab who was Japanese gave her talk in English because she was from OIST, right? But the funny part was, after we started giving our presentations in English, and the people there realized that we didn't speak Japanese, some people just decided to ad-lib their talk in English. And it was great, because like you could tell they were ad-libbing it. And it was really funny. Like, I mean, it wasn't funny. Like, it was just interesting. I thought it was really cool. I don't know. MPV, full screen that guy. Here's our animation. It goes from that to that, and there's our lines. Wonderful. I feel like I might want to do a different seed. And also we probably want a few more frames. Let me try a different seed where these lines aren't all clumped up on the side here. Let's just run this one more time. And I'll also add a few more frames. And then we'll start working on the last bit. So the number of frames looks like 500. Let's change it to 1,000. So we're doubling the number of frames. And the random seed... srand? Let's change this to, I don't know, 1, 2, 3, 4. Let's go. G++. Let's go. Let me catch up on chat. Sorry, I just hit the microphone. Almost all chemistry. Let's see. You know what Euclid's Elements is the second most read book in the world. Probably next to the Bible, right? Time for them to computerize and translate everything. One common language. Honestly, I wish we had one common language. That would solve so many problems. I read that too, but I wonder if it's true, to be honest. The thing is, the lingua franca changes and can easily change. Right. Did Lavoisier write German? I don't know who that is, but a chemist. I should know that name. You know, we never had a chance to know ancient Egyptian script, so we lost that knowledge. For my bachelor's thesis, I was dealing with a certain molecule that I cited the original paper of the discovery from 1870. It was Russian writing in German. Oh no. That sounds pretty hard to understand. Wow, that's cool. I forgot who it was. I read some math papers from the 60s, and they're much harder to read than the modern ones for some reason. I don't know why, it's just not the language. It's not the language. I can see importance of English changing if we don't protect it. I just learned a new word, triplicate, to multiply by 3. So, as far as English, like old papers are concerned, I do feel like some old papers are harder to read because they just have more math in them. Okay. That is a lot of lines. I feel like we don't need 20 of these. Yeah, because at some point it's on the triangle, right? Like, we don't need 20 points. Let's do 10 points. And let's also change the seed again. Let's just change it. I don't know. What's your favorite? Someone in chat, give me your favorite number. Doesn't matter what. Just give me a number. It doesn't even have bounds on it. Just give me an integer number. 1337. Let's go. I said at the end I specified integer number, and I'm glad I did. Because also, is this a bound? Like, is this anything less than 81234? 13 plus 6, 3i? Is that integer? Maybe that's integer, but it's integer in a different space. As a hobbyist linguist, y'all, a world language is not happening because even if it were possible for a language to be perfect, it cannot be controlled or preserved in that state. Yeah, that's a typo. Oh. I thought you were saying any number less than this one. We could do a Mersenne prime or something, I guess. But 1337 was good. We'll use that one. That was a mashed numbers on the keyboard. I find it funny that you were like, you mashed numbers on the keyboard, but IE Bogey still got you first, you know? Let's see. Only manages to be consistent because nobody speaks it. People have tried to make the perfect language. The true world language is x86. Actually, there's some truth to that. Funny flywheel, unfortunately, you were a bit late. 8675309. Oh, that's a good one, though. 8675309. If this one gives us a bad visualization, we'll do that one. Twitch is the next random number generator. Oh, what I should have done is I should have told everyone to open up a terminal and try to quit Vim. That's what I should have done. That's the only true way to get random numbers. Okay, this looks pretty good. Yeah, okay. So go there, there, there. Okay. When's it on? There. Now it's on the triangle. So how many points until it's on the triangle? Let's see. So maybe we should do all 20. What I want to do is I want to have the line changing in opacity. I want to make it be like darker and darker as it moves along. But for some reason the alpha value changing isn't. Is it changing? Is the alpha value different? Let me see. So here are all of our lines. Let me pause it at the end, and I'm gonna print screen. See, that's the interesting part. Okay, let me just print screen, and then we'll open this up in GIMP, and we'll take a closer look. GIMP screenshot. .png. Okay, so here's our triangle. Let's zoom in here. What I was hoping to see was that this line here, let's change the color also to red, I guess. I was hoping to see that this line here was like a lighter shade. It is more opaque, actually, or less opaque than the first line, which was this one over here. So I think this is what I want. Let me think about it a bit. It seems like it does look like the thickness is changing, doesn't it? Which isn't what I coded in. I coded in that the opacity should change, which probably has a similar effect. Let's see. It's cool, only manages to be consistent because nobody speaks it. Yeah, that's fair. The true world language is x86. Actually, Greek itself is not really preserved. Twitch is an X-rand generator. Like delta is not delta anymore. It's theta. Delta. What is delta? It seems like the thickness is changing. Were the points different shades of green? Yes, so the idea was that the points would, let me explain. So the points here were supposed to become closer and closer to blue. So now I want the points to get closer and closer to red. No, closer and closer to blue is fine because I wanted it to shade in to the underlying triangle is what I wanted. So like at some point here, let's just, I can just open this up in GIMP again. So at some point here, which was the last line, there, it's hard to tell that was a new point being generated. I wanted to kind of shade into it. So that was why I changed the color of the points as it went further in. It looks like it gets closer and closer to being on the triangle, but it always remains in the exact middle of an inverted triangle, one level deeper each time. So my theory is that it never gets on the fractal, but gets close enough and bounces around everywhere enough to approximate its look. I actually think there's a lot of truth to that, and I think that's actually probably what's happening. So I think you're right. I should probably update the algorithm archive not to say on the triangle, but to say close enough to the triangle that it approximates the Sierpinski triangle. I think you're right. I think I need to make that change. That's a good point. So I'll just put this down here, close enough to approximate Sierpinski. Yep, good point. I definitely should say that. Delta, what about theta? Theta is the same. I assume they mean ancient Greek versus modern Greek. I thought it was Felta, like SNL fraternity. I felt a thought. What is Felta? I mean the TH, like in that instead of D everywhere. Is the frog that always jumps halfway to the wall. Okay, I'm gonna have this keep playing in the upper left-hand corner. Oh, I'm sorry, I just screwed up with the music. My bad. I'm gonna have this play in the upper left-hand corner, but there's something I have to do. Here's the next thing we need to do. I'll worry about the line color in a bit. What I have to figure out now is how to get these dots to not appear. Let me open it up in GIMP so you okay, so see this dot here? Let's do print screen. I'm gonna open that up in GIMP. So all of the dots where the lines are going to appear are here, here, here. You see all the dots, right? And what I really need to do is that I need to make it so those dots are not present. Now that is actually very difficult to do with GathVL. And that's what I'm trying to figure out how to do right now. And you might ask, why is it difficult to do? It's because I don't think you can keyframe color. You can keyframe everything else, but not color. So I could make them opaque, right? So I could make them opaque. That's one thing I could do. Or I could save all of these. I could save all the lines and add them to the world later. If I wanted to. I need to think about how to do this. So there's two ways to do this. What I usually do is I don't add the object until the frame before it's used, right? But that's hard to do in this framework because of the way I put it in. Another thing I could do is I could have the opacity. I could have the opacity be set to 0 or 1. So it's no 0. So you can't see the point. And then right when the line is starting to be drawn, we change the opacity. So let's see if we can do that. That's the first thing that we're going to try. The dots do not obstruct the path of the line. They are the initial point. So like here, what you can see is that this dot right here corresponds to the initial point of the simulation. And this like the next point. I guess that's the next point, and that's the next point. So I don't want these to be shown until the end. So I need to make them not be shown. I'm gonna play this in the upper left-hand corner, or actually I'm gonna play this for a bit. It's on loop, and then I'm gonna catch up on chat, and then we'll move on to that. So here we go here. Okay. Delta, what about theta? Let's see. It's a frog. There's a lot. Yes, that letter now reads like that. They're already opaque. You just want to make them transparent. Right. So I want to set the opacity down is what I want to do. Do the dots obstruct the path of lines? Oh, sorry. It's actually theta. I see. I feel like every time I pronounce a Greek word or Greek character, I'm mispronouncing it. Like Ada or Nu or Kai. I'm like, I know I'm mispronouncing it. I know this isn't how you actually pronounce it. But this is the way I was taught to pronounce it. So this is the way I will pronounce it, you know? I don't know. Okay, so let's let this play and let's change that opacity. And then we'll go from there. Oop. Cool. So actually, I'm really happy with the amount of progress we've made on this stream so far. Like, you know, we did a lot with Klima. And then we did some stuff with the algorithm archive. And now we're finishing up a visualization for the next video. And I think we've gotten pretty far. Like, we're doing pretty well. It's just a matter of just continuing to work on this and going from here. I guess you're pronouncing it correctly according to English rules. Almost all people mispronounce Greek characters. Right, because I feel like the knowledge of Greek, like the knowledge of Greek characters is just ever present in mathematics, right? So pretty much everyone is used to seeing Greek characters, and so everyone has to pronounce them, and they just pronounce them however the heck they feel like pronouncing them. And that's different in every language, you know? Okay. Cool. Okay, so let's go. So we're gonna have this line, and I'm gonna try to add an animator to this ball. So we're gonna say yank paste, and we're gonna say clear. And if not clear, let's just do black. So we're gonna do 0, 0, 0, 0. Okay? And we're gonna do ball add animator. So this is gonna start as no, this is fine. So we'll do line color here. But I'm gonna move this line down here. And we are going to initialize our arrow as clear. Okay, so now we do yank 3 yank. We're gonna paste it up here. And we're gonna do add animator, vector animator, and we're gonna do arrow.color. I don't know if I can do this. This is the thing that I'm actually a bit worried about. And we will do, let's see, clear 0, 0, 0. What do I want? I want it to go from clear to line color. And the frames in which it's going to do this is going to be, let's just see what happens. I'm not convinced this can even compile. Or it will even run. Let's see. Oh, CLR. Because I'm bad at naming things. Right, so that gives us a huge arrow. Let's see. Let's go ahead. Clear. Clear. Let's see what we have. G++. New matching function for call to vec animator. Let's see. Yeah, so we can't change the color with time, which isn't great. So now we have to think of another way to do this. So what I'm going to do is we can do two things. One, we can cover up the point with another little black ball at that location. No one's going to know if we do it that way. Can we change the line width? Is that something we can change? Let's see. So let's go into GathVL, and let's see if we can change the line width. Because maybe you can just make the line width change. So CD in projects, GathVL, ls here, CD into source, animators, ls, and let's go into vi vec animator, cpp. Okay, so let's go into objects, CD into the Archimos. Thanks so much for following, really appreciate it. So we're going to CD into objects, ls here, CD into line.cpp, sorry, vi line.cpp. What do we have here? We have, that's not what I want. CD include, ls, CD objects, ls vi line.h. So what do we have? We have color, start, and end. Yeah, so we don't have line width as a thing that can change. Can I change the line width with time? So let's do grep width. That's a lot of points. Let me catch up on chat, and then we'll talk about this a bit more while we try to figure it out. Update.keys, VS Code is alerting me to consider iterating the dictionary directly, so I'll do that instead. Let's see. It used to have rules, but then the Fire Nation attacked. And ancient Greek phi was pronounced P. Interesting, in a word. Many concepts in math come from many languages. I think pronunciation is important to maintain the origin of these concepts, like eigenstuff. According to Wikipedia, phi is in ancient Greek wasn't phi, but hey. Oh, interesting. So Rihi, thank you so much for following. Really appreciate it. Phi is like phi. Yeah, that's how I would pronounce it. Do you know that guy Schwarzschild? I don't know how to actually pronounce the name. I guess Schwarzschild. But I usually hear it pronounced Schwarzschild. Let's see. I guess you English folks are gonna say his name Schwarzschild, right? Didn't Hawking kind of append the Schwarzschild radius? Did I show you my mathematical noise? I don't think you did. Feel free to link it and I'll take a look. Okay, what do we have here? Visualization test scene.cpp. Let's check that out. Vi scene, source scene.cpp, width, line width, Cairo set line width, get 3. So I'm gonna do something dumb, and I'm just gonna put this line in somewhere else. What if yeah, let's just go down here and let me see if I can change the line width with time. So we're gonna say if I is greater than 100. I don't know. I'm just making things up as I go along. Then we're just gonna change the line width at that stage and see if we can do that. I don't know if we can, but that's what I'm gonna try to do. Let's go. So we're gonna set it to be 100. Yeah. Yeah, so we know this arrow.color thing doesn't work. So this is gonna have to be line color. This should compile. I'm going to go ahead and remove the clear line above it. G++ does not, and that's because context.get does not exist. So where do we have that read in? So am I able to grab the context? So it's context.get. Where is context defined? Context, Cairo, create surface, get, Cairo, destroy. I probably can't get it to be drawn there. Right, so here's my issue. I'm gonna go ahead and full screen this guy here. Okay, so when we start the visualization, all of the points are already there when they shouldn't be, right? So I don't want these points to exist when I start the visualization, right? So what I tried to do is I tried to set the opacity such that in setting the opacity, you know, we add a vec animator to change the color. So then the color can change whenever we need it to change, right? Now, what you might be saying is, okay, why not just, you know, why not just not add the object until you need it? And so then then I'd have to put it down here and the encoding step. And that's fine, but I need to figure out how to put the encoding step. I basically just need to wrap all of this into that encoding step. But that's the problem, right? Because we have the vec animators being added there, and it's just, I need to rethink how I'm going to shape the code. So I'm debating whether I cover up those dots with a little black ball, which I can do pretty easily, or if I, yeah, let's just cover it up with a little black ball. That'll be the easiest thing to do. Let me catch up on chat here. Oh, the color animator doesn't work though, is the thing. Or at least I couldn't figure out how to work. So here's what I'm gonna do. I'm gonna yank and paste this up here, and then we're gonna do clear. This has been a long-standing issue with GathVL, so it's not like this is a. Oh, is there a specific color animator? Is that it? Okay, that might be what I did wrong. I understand. Now, I think I understand now, and I apologize for that. So we're going to make this be clear to start with. So I can't just change this to be color. There's an actual animator for color. Let's see. CD animators, ls, CD source animators, ls. Nice. Yeah, okay, that's what I'm looking for. VI color animator, perfect. I knew it was here. Okay, so let's go down here, and we'll do color animator. I guess I can just do, what do I need to give it? So color pointer, frame, start frame, end frame. Hue. It's okay, it doesn't have to be smooth. Look at the header file. Yep. Animators. Let's see, color animator. So we need start, end, color pointer, start color, end color. So the color pointer should be. Oh, sorry about that. I'm in the wrong file. I think this is right then. So, oh, but not location. So it needs color and color. So we'll do clear. See if that works. Ah, that's my bad. See what happens. G++. Color animator was not declared in the scope. Okay. What do we have? Look at the header file. Let's see. Some sort of domain warping that I invented. Let's see. Schwarzschild? Oh, is that how it is pronounced? Sorry. That sounds correct. Schwarzschild. Yeah, okay, my bad. One day I'll learn German, but that's probably never actually going to happen. Yeah, let's see what this looks like. Right. Oh yeah, this is super cool, man. Nice. Yeah, it's cool. Yeah, I've been wanting to do some noise algorithms actually for a while, but I haven't, because I just haven't. But there's a lot of cool things that you can do there with random number generation and stuff. It's super cool, man. Good job. Oh, am I supposed to hear the noise? Oh, well, no, I thought it was visual noise. It wasn't like sound noise as well, right? Sorry, I don't... Okay. It's visual noise, right? If it's sound noise, I would be very surprised. There's no noise in the noise. Yes, that's what I thought. So it's visual noise. Perlin noise. Yep, that's what I thought. Cool. What are the lines bouncing off? You're talking about in my visualization here. You're asking what these lines are coming, where these lines are coming from. This line here, those lines. So what are we doing? What we're doing is we start with 3 points, A, B, and C. And then we have 3 functions, right? One that will output the midpoint between the point and A, another that will output the midpoint between the point and B, and another that will output the midpoint between the point and C. So what we do is we take in some random location. Here's a random location up here. Let me change that to be pink. And then it chooses a random function. And it just goes over here, you know? And then that chooses a random function, goes over here, then over here, then over here. And slowly and surely it converges to a point that's really, really close to the Sierpinski triangle, right? And at that point, no matter what function it chooses, it's going to remain on the Sierpinski triangle. So what I did is I did the simulation for 1,000 steps, or a couple thousand steps, to generate the background triangle. And then I redrew on the first 20 steps, where the first 20 steps are these dots here. And so I'm saying that we started here, then we went there and there and there and there, and we moved all around until eventually you start to notice that all the points are on the triangle, right? And that's the point of the visualization, just to show that within the first 20 steps, you eventually converge to a point that's close enough to the Sierpinski triangle that all other values, no matter where this point walks on, will remain close enough or on the triangle. So that's that. Reddit is depressing. I know, I'm sorry. If only we could experience 2D plus 1 sound. They go until they hit the center of the triangle, right? They go until they hit like an edge of the triangle. Let's see. I really shouldn't visit that site. I blocked Reddit. I still sometimes go on it, but I block it. The algorithm is called iterated function systems, also known as a chaos game. Could this statement be proved someday? I suppose someone could prove it. That would be interesting. Yeah. Okay. So what are we going to do next? So color animator didn't seem to work, but that's probably my bad. So let's go back to the GathVL thing, and let's see where color animator is. I've uninstalled the app. Oh, you use the app, right? Yeah, the app is dangerous. I don't use the app. Also, I don't like the app. It forces you into portrait mode. Who uses portrait mode? Like under what situation? It just doesn't make sense. Why would you use portrait mode? I don't know. It's weird. I don't like it. So let's go into the color animator here. It's called color_animator. And here it says, color animator was not declared in the scope. Did you mean vector animator? Third-party apps for the win? Yeah. Let's see. Template argument, deduction, substitution failed. Void add animator. And if GathVL vac animator. Cute. Huh. So the question is, where's the color animator? BI source, animators, color animator.cpp. We have update. Again, this should be fine. I'm not seeing anything weird about this. So let's go into VI include animators vector animator .h, and we have vec animator start update constant frames. And let's go into color animator. .h. Color pointer, start color, end color, override color animator, int start, int end, color pointer, color, start color, color, end color. Do we have an example of this working? Let's do grep-rl color animator. Include animators color, source animators, GathVL include animators color animator.h, object.h. Can you make an announcement in the Discord that I need help with AA Pi PR? Right, yeah, I can say that. Color animator, you get index, object.h. Oh boy, what is the issue here? Man. Where would color, how? Color animator was not declared in the scope. Is it just CLR animator? Oh, you want to make like an announcement. I see, I misunderstood. Maybe CLR animator. Let's try that. No. Error, no color animator was not declared in the scope. Let's see, no matching function for call, line, add animator, expression error. Okay, so I don't think the color animator then exists for a line, is gonna be my guess. Let me try changing the color of the ball. No, okay. I just thought maybe. If I change this to vector, G++, that does not work. Nope. Then yeah, I don't know how to call this. Is your nickname related to the Python framework Flask? Let's see. So I have no idea how to call the color animator. So at this point, I think we're just gonna have to do something else. Yeah, I can't figure it out. Hey Zabida, how are you? I'm not Dono. Let's see. My screen name predates a package several years. Fair enough. Okay. It's been a long time since I watched you again. Yeah, how are you? I hope you're having a wonderful time. Okay. So I can't figure out how to get the color animator to work. So I'm just gonna not use the color animator. I wish I could. Like, that's the thing. I just don't understand why it's not working. So let's see. It just says color animator doesn't exist. Did I make the... Let's see. Make lib? Clear. Make clean. Make lib. Let's just see what happens. Maybe for some reason the library is being, like, weird. I don't know. I'm just gonna try something. Rebuild the library and see what happens. Let's see. It's the first time for me to see you when you're sitting. Yeah, I know, right? I had a standing desk before, and I kind of prefer it. I really don't like sitting in this chair for this long. G++. Yeah. Candidate template, class A, add animator. What's going on? Clear. G++. Maybe I have the wrong animator there as well. There's color animator. Oh. Okay. I just had to rebuild the library. Let's go. /Sierpinski. Let's see what happens. I have no idea. Let's go. This might be exactly what I needed. So thanks, Gathros, for that. Okay, let me get some water. We have about 30 more minutes left in stream. I've been streaming for about 3 hours and 30 minutes, something like that. I had to rebuild GathVL. That was my issue. For some reason, rebuilding it. So I made clean and then made again, and then it worked. I don't know. I have no idea why. That's just what I had to do. Cool. Okay. So let's see how this turns out. Yeah, color animator didn't exist. So I suspect, I don't know how. I guess I was working on an old branch and that didn't have color animator added, and then it got added later. It must have happened a while ago. But it's okay. We're getting there. So again, guys, if you have any comments, questions, concerns, anything like that, feel free to let me know. The way I see it is there are no stupid questions, just stupid people. No, I'm kidding. There's no stupid people either. The way I see it is some of the stuff we cover is kind of complicated. So I'm not expecting everyone to understand everything I say. I do expect, though, if you have questions that you ask it in the chat, I do what I can to answer it when it appears. The points are still there. See what happens. No, the color animator didn't seem to do anything. But I think that's because... No? Let's comment this out. So in this case, we should see no lines whatsoever, because the line color should be clear. Color clear. I screwed this up. That was my bad. Never mind, I'm an idiot. I figured it out. That's what I was looking for. Try it again. It's a tricky tense problem there. Is it made clean or maked clean or make cleaned? I guess make clean. What did I say? I just had to make clean. I think I said I just had to make clean. I think it was also past tense. Cool hair. I think it's because of the COVID-19 isolation. In my country, hairdressers have been closed for 2 months. Yeah, that's my hair. First time I've ever put it in a ponytail. But it's okay. I kind of wanted long hair for a while, so I'm just letting it grow out. It's the perfect time to do it. You know, I don't really have any excuses. So, I mean, like, basically, I've wanted to grow my hair out for a long time, but usually there's something that comes up. You know, like a thesis defense or a wedding or something like that. But here it's like there's nothing on the horizon. Hairdressers are closed. I can make plenty of excuses to grow long hair, and I'm like, let's do it. Just for once. It's going to look bad, but, you know. I just don't go to the barber, so I just cut it at home. Yeah, well, that's because honestly it looks kind of bad right now. Like these sections here kind of come out. I don't like that. And then also like this section isn't quite long enough that I can swipe it behind my ears. So it's in the awkward growing out phase. But like it'll get there. It'll get there, you know. So I'm trying it. We'll see. MPV, come on. Okay, that ain't bad. That ain't bad. Okay. Actually, I kind of like that effect. It's growing and like appearing at the same time. Yeah, that's a nice effect. I think that's fine. Nah, okay, let's change that effect. So what we're gonna do is we're gonna go here. And we will do, let's do 59 and then 60. Let's go here, G++. And the other thing I need to do is add the ball to frame 3. Yep. So we have to add world somewhere. Add layer here. So G++, /Sierpinski. Let's go. Let's see. I just asked my dad to shave it for me. I regret it. I'm sorry. I didn't go bold. I just have it short. Yesterday I shaved my father and brother's hair. Maybe I can do a favor for you too. Nah, it's okay. I have left my hair grow for about a year. It's just barely too short now. Oh, wait, so you grew from nothing. Yeah, I can understand. Change the start and end color to be the same? Wait, why do you want to change the... What would that do? Changing the start and end color to be the same? Oh, do you want to fade everything out? Yeah, we could do that. Actually, now that we have this color animator, we have like a whole new like group of things that we could do that I hadn't considered. So there's no fading. I think this is okay. We're gonna see what happens. So I made it all fade in one frame. So it basically just appears. And I think that's exactly what I want to do. So we'll see what this looks like. I think I will be happy with the results. So we'll see how it goes. Oh, but there's one thing I need to figure out, which is why the opacity doesn't drop all the way to 0. And I'm gonna guess that's because we need, yeah, so let's take a look at this visualization. Here it is. Oh. Okay. Let's make this 5 frames. 5. Okay. Yeah, let's try that. And then let's also do I+1 here. Yep, and let's see what happens. So it's gonna be I+1 over 20. Yeah, this should work. Let's just see what happens if we do G++, and let's go. So if you change the start and end color to be the same. Oh! You're right. I understand what you mean now. I misunderstood. That's exactly what I want. Perfect. So this starts at 60, so let's do 60. We'll do 59. Actually, wait, it draws from... So what if we do 60 to 61? Yep, that's what I want. I just didn't understand what you meant. I apologize for that. I need that color. Got it. Nice. So yeah. So we have 30 minutes left in stream, and I'm trying to think of what else we need to do. So we have, so once this animation is mostly done, I'm relatively happy with how this animation turned out. We have to go back and update the Hutchinson animations. Now, I don't know if I can do that in 30 minutes, but we'll see what I can do. So I'm gonna commit what I've got. And I kinda need to stretch. I'm really just like, my back is hurting from sitting in this chair for so long. Cool. Okay. So let's see. See, Amaris, thanks so much for coming in. Have a wonderful evening, and I will see you around next time. The Seven Bridges of Konsberg, but now it's Kaliningrad. Kaliningrad? I don't know what that is. So let's see. Oh, man. I'm not used to sitting for this long, and it's killing me. I don't know how high school kids do it, honestly. I know I was a high school kid at some point, but I guess they're not sitting. Like, they're only sitting for 45 minutes, and then they walk around, or like an hour and 30 minutes at most, and then they walk around. So it's probably not as bad as sitting in the same place for 4 hours, but boy. So let's take a look at this. It goes from red to blue, and then we should be able to draw the lines. Perfect. And then I think the only thing I don't like about this visualization is that the line color doesn't seem to be fading as much as I had hoped. And I don't know why that is. So I guess what I'm going to do is I'm just going to output something. So I'm going to output the value of this guy in here, which should just go to 0. That's what I would expect. Let's run g++/Sierpinski. -9999. I was expecting 0. Control C. Double N minus O. Should be 1 minus I over 20 is what I'm looking for. I think that's what I want. g++/Sierpinski. So those are all 1 because I think they're cast onto an integer because of the integer division there. So 1.0 minus I minus 1 over 20. g++/Sierpinski. Those are all still 1. 20.0. Okay, so that goes down to 0.1. But I was expecting it to be... let's see, so it's probably 1 plus I. Okay, so that drops all the way down to 0. Okay, so we're going to do... what am I looking for here? So that's the actual thing that we want. So let's go ahead and... what? We want to go down here. So the ball color then should be just double. So there's no double of n in here. It should just be I over 20. And this should also be I over 20. And we need to make sure that these are cast onto floating point values. So we'll do this. Oops. And then we also need a 0.0 here. And then down here, for this color, we're going to do 1 minus that divided by 20.0. And this should be the right animation now. So let's go here to g++/Sierpinski, and let's see what it turns into. We have quantum computers now, so why not hearing... why are we not hearing anything mind-blowing done with them? So the truth is we don't really have quantum computers yet. I mean, we've got things that are close to quantum computers, But there are only really like 2 or 3 algorithms that quantum computers can do better than classical computers. And the quantum computers we have are not yet at the stage where we can actually use them for solving these algorithms, right? So we're at the infancy. So the truth is, yeah, we do technically have quantum computers, but they don't really work the way quantum computers are supposed to work. There's a lot of like nuances to this. It's the answer I'm giving you, but that's kind of the gist of it. So yeah, there's a lot of work that needs to be done there. And some of my old work was somewhat related to that. But yeah, we don't really technically have good quantum computers is what I should say. How many qubits? I don't know. I mean, I don't know the state of the art. I'm sure there are people, I know people who do know the state of the art and could tell you the exact number for the best quantum computer out there, but I'm not that person. Let's see. So we have this guy. Now we should see the dots appear. Those are blue. Those are definitely blue. Yep. And this line does not seem to be fading at all. Okay, cool. So, what's the issue here? It has to be a floating point thing again, right? Right? Let's just see out some stuff. So we have... Oh, so why is that blue? So it's going to be 0... It's going to be 0. Let's see. So it's 1 minus I. Oh, these are the same number. They shouldn't be the same. One should be different. So it should be I over 20. So what color do I want it to go from red, green to blue. So we want this to be the right color. Now for the opacity, why was that not doing anything? Can I just output? stdc out line color dot A, I guess. G++ /Sierpinski. It does drop to 0, so we should be able to see it. Eva Cadavra, thank you so much for following, really appreciate it. But yeah, so I'm sorry that I can't give you a good answer for the qubit thing. The opacity does definitely change. Yeah, it does definitely change to 0. Yep. Okay, well, whatever. This visualization is close enough to where I want it that I'm happy to close the book on it. Let me show the other animations and see what we need to do with that. Because there's some stuff with those other animations that we still have a lot left to do. But I think Google over-exaggerated theirs. Yeah, they made some claims about quantum supremacy and stuff like that, which are very hard to justify. I'm not saying they're unjustifiable, but I am saying they're very hard to justify, especially with the data that they had. So it's, I mean, look, quantum stuff is confusing. It's hard to make any claims about anything. I understand to some extent, but yeah, making claims that, you know, quantum supremacy has been achieved, it's just kind of like a bad name, you know, and they caught a lot of flack for that. So I think they've already, you know, been whipped enough for that. I'm not even gonna call it a mistake, but for that PR claim. Okay. Yeah, so now it's just pure blue, and it's turning green. I think I mixed up the green and blue. The line is not at all fading. So, okay, so let's change the color here. So the ball color will now go from 1.0 minus that, and then we'll go I20. Yeah, I don't know how I made that mistake. Okay, so we'll get this done. Sierpinski, let's look at the other visualizations and see what we need to do that. Will quantum computers blow through our current cryptography techniques? That's what people keep saying, but I don't really know if that's true. What are we doing here? So we are writing a chapter for the algorithm archive on iterated function systems, which are ways in which people create fractal-like systems. So what we're doing here is we're showing a visualization of the chaos game, which is one way in which people visualize iterated function systems. We have other visualizations as well. For example, 1 second, where is it? It's up here somewhere. For example, video_Hutchinson.mp4. This visualization here, where we have all these points being generated in order to generate a bunch of children. This is another way you can use iterative function systems to generate the Sierpinski triangle. The idea here is that essentially you start with 3 points. So point here, here, and here, and all 3 points move according to a prescribed movement. Either they move halfway towards A, halfway towards B, or halfway towards C. And all 3 of these points are going to generate 3 kids, and those 3 kids are going to move in one of those directions. So this guy's going to generate a kid that moves here, here, and here, right? And then all of those kids make kids, and all of those kids make kids, and all those kids make kids, until you create an animation that looks like this. So this is the generation of all the children, of all the children, of all the children, down to 7 generations. It's very computationally intensive, which is why we also show the visualization of the chaos game, which is where you just take 1 point and you have it just randomly move about. And when it randomly moves about, it very closely approximates the Sierpinski triangle. So these points are all on the Sierpinski triangle itself. But the chaos game is very close approximation to the Sierpinski triangle. So let's show that one more time. Oh, sorry, I just hit the music. Yep, here we go. So we're gonna full screen that. So here's what you would see for a visualization of the chaos game usually. It's just a bunch of random points. So what happens is you start at this point here, and then it moves here and here and here and here. It just keeps moving about until eventually, like on this point, it's very close to the Sierpinski triangle, right? Like, which means no matter what function you take, it's going to stay very close to being on the Sierpinski triangle. And so that's the visualization we're seeing here. Just all the points bouncing about. And again, all of these points, after maybe, we'll say here, I would say, are definitely on the Sierpinski triangle, or they're close enough that it's going to be a very good approximation. So that's what this visualization is trying to show. There. So those are the 2 different visualizations we have. What's with the Twitch chat tool? We have algorithms for a thing we saw called Game of Life, like something. This is not related to the Game of Life. All right, gotta go. Thanks so much for all the help, Cathro. Seriously, it's super great seeing you in chat, and I hope to see you again soon. I really appreciate you coming along and especially helping out with this, because it's like I know Gathviel needs some examples and stuff like that, but I think I should do that. I think I should write some examples for Gathviel and maybe get the development up and all that kind of stuff. It's IRSSI, right? Flask is right. Unfortunately, guys, I think I don't have time to really work on the next animation so much. So I might have to do that tomorrow. I do have to leave in like 10 minutes. I'm really sorry about that. It's what I have to do. Right, no doubt. Work on your exams. That's first. That's what has to come first. Like, what I wanted to say, I'm not trying to say do more work. I'm trying to say thank you so much for the work you've already done. That's what I'm trying to say. And I'm hoping that comes across, because I genuinely mean that. So, okay. So what I want to do is I want to go here. Oh, we're on Twitch. So let me know who you want to raid at the end of Twitch, at the end of stream. We have Dowright, Rocket Sage apparently just started. Let's see. We've got Fractchemist, CM Griffin, Lana Lux, a bunch of people. I feel like it's been a while since we raided Lana. Maybe we do that. But again, we still have 10 minutes. So we have some time to talk about animations. And if you guys have any questions or anything like that, now's the perfect time to do it. Anthony. Anthony writes code. Yeah, we could do that. What's he working on today? Setting up 20.04 development environment. Right, yeah, let's do that. Sounds like a Linuxy thing. Cool. Let me get some water. So we'll raid him at the end of stream, unless other people have other ideas that they want to raid, and we can put that into the pot. Let me go ahead and commit what we just did. So let's do wget git add Sierpinski.cpp, and we're going to do git commit -m, adding new visualization, a visualization for Sierpinski, for Chaos Game. Okay. And we'll do git push upstream master. Okay. Sorry, origin master. I'm getting a bit tired. Okay, let's see. Lana's good too. Let's see. I like to see how game models are created. Anthony's a cool guy, mostly works on his own text editor, but he's checking out a new Ubuntu version. Watched him earlier a bit. Yeah, if he's doing Ubuntu stuff, like we do Linux stuff, that seems like a good thing to move to. Okay, so there's one more visualization I want to show you guys. So you just saw this visualization here, MPV full screen, and I think this visualization is close to what I want to show. If I talk with it, it makes sense. So I think that's what I want it to be. The other visualization I just showed you guys was this video here. And this again is close. I need to slow it down so each generation generates kids a bit slower, so we can more easily see that, you know, at the very start here, it's not a whole bunch of kids moving around. In fact, let me just go ahead and do that right now. I bet in the next 10 minutes I could get that done. So let's go in vi sierpinski.cpp Hutchinson. Here's our square Hutchinson operator, which is another fun one, but we'll worry about that later. So we'll go to Sierpinski Hutchinson here. Here we are. Okay, so the big issue here is that our draw frame is only increasing by 1 every time. So what I'm going to try to do, let me increase this by 30, and let's just see what animation pops out. So let's do Sierpinski Hutchinson again, remove the chaos animation, and then we're going to do g++/Sierpinski. Can we visualize infinite zoom of a fractal? We've already done this before, actually. CD Projects, Simuleos, Fractal, ls, CD into images. CD into images, ls. And if we do Mirage, fractal zoom, 000.png. Here's our zoom. Right, so we did this with the Julia fractal, I guess because we wrote this in Julia. But yeah, we've done this before. I haven't written the algorithm archive article for it, nor is this really an algorithm, so I don't know if it necessarily fits into the algorithm archive, you know? See you, Trash Talk. Thanks so much for coming in. Have a wonderful evening. I hope to see you next time. Okay. So that looks like it's done. So let's go ahead and run MPV. So we have these 3 points and... Okay, so what's happening here? It looks like all 3 of the initial points followed function 1, function 2, and function 3. Yes. So this is kind of like the visualization I want to do. Yeah, okay. Almost there. So what are we going to do? We're going to do draw frame plus... Where are we? Draw frame. Here it is, plus 30. And then we're going to do 30 divided by I. Is that what I want? So I want the first generation of kids to be generated very slow. Then I want the next generation of kids to be generated slightly faster, and then faster and faster. So let's see what happens. We're going to do g++/Sierpinski. Give it a run, and we'll see what we got. I think we live in a simulation, probably. I don't know the actual... Like, there's someone who believed that. Tripetti, thanks so much for following. Really appreciate it. Okay. Is it done? No way. MPV, let's go. Was that a segmentation fault? Floating point exception. Let's seal that. I think I need to do... so we're going to run g++/Sierpinski. So it must be at some point... how's that happening? Draw frame plus equal ceiling of 30 over I. What is your issue? Let's output I. STD, C out, I, next line. g++/Sierpinski. Oh, okay. Yeah, I understand that problem. Yep, okay, I gotcha. That should do it. Hey, Cropep. How does it affect our lives? And how do we detect that, though? I have no idea. We want to live in a simulation. We can't break the fourth wall to prove it. Let's see. Try to. Bonjour. Hey, how are you, Cropep? Unfortunately, you caught me at the end of stream today. I've already been streaming for 4 hours. I've got about 10 minutes left in stream where we finish up this animation. But yeah, so I'm streaming a bit earlier on weekends, just because I feel like streaming a bit earlier. And in particular, it's kind of a nice day outside today. So I mean, I know I said I have to go, but you know, after a 4-hour stream, I think it's fair enough to say that. What I'm actually going to do is I need to go work out. I haven't worked out in a while. It's a good day outside. I'm at a lake house. So I'm just going to go for a swim. I'm not going to tackle that comment, Prutz1311. I don't want to start a fire. So anyway, we'll let this render and then we'll go from there. But yeah, so yeah, let's see what this looks like. I knew someone Okay, so we have those 3 points, and we have 1, 2, 3. Ooh, 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 ooh. That was the thing. Man, that looks so cool. Oh, I love that animation so much. Gosh, that's cool. Okay. I know it's too fast, but like, I know it's too fast. I know that, but it's really cool. New channel animation. That'd be, yeah, it will be new animation for my channel. So we'll draw frame plus that, and then what do I want to do? Perhaps if someone raids you, yeah, we could do that. Right now I'm using the Batman Monte Carlo. So CD projects, Monte Carlo. Actually, CD storage, videos, MC_1 ls. I think if I just go MPV MC_1.mp4. Right now I think, oh no, that's not the right one. There should be like a Batman one. MPV video.mp4. Nope, that's my actual video. Batman.mp4, MPV Batman.mp4. So right now I'm using this. It's a Monte Carlo animation of the Batman symbol. So that's my current, when people raid me or host me, that's my go-to for that one. I kind of like that one. Is this on the Algorithm Archive? This is on Simuleos. It won't be on Algorithm Archive. Let's see. Seeing how quantum mechanics works is so weird. Maybe have an existential crisis. Make me have an existential crisis. Let's see. Nimoy, thank you so much for following. Really appreciate it. Oh, and that animation is an animation of Huffman encoding. So, do you have quantum mechanics visualizations? I did a long time ago, but I don't know where these went. A while ago, we did quantum circuits, and we had some visualizations of those. Yeah, ask Vexitos. He probably knows. So let's see. We're gonna do 1, 2, 3. So what I need to do is, I think I know what I need to do. So we should have a level argument in here. Do you know Eugene? I don't know him. Sorry. So we're gonna do this, and we're just gonna do draw frame. Sorry. Plus equals 30. Let's see what this does. G++/Sierpinski. And this should make the animation a bit nicer. He does a lot of scientific animations. Yeah, so there are a lot of really good people who do a lot of really good animations on YouTube. I don't know if I would consider myself to be one of them. I'm a big fan of the animations we make, but also my videos aren't necessarily all animations, right? Like there's, I don't know, like my videos are weird. They're somewhere in between like Tom Scott and 3 Blue 1 Brown, and I admit that it is a weird type of video to get into, but I genuinely like all my video content. Yeah, there's bits of it I don't like the music is too loud in the background of some of it, but honestly, all the videos I've put out, I stand by. I like all those videos, except for Eggy Experiments. Like that one, maybe I don't stand by that one so much, but everyone wants me to keep that one on there, so I keep it on there. What did you call the process for Batman animation? That was called Monte Carlo. It's Monte Carlo animation. If you want to learn, or Monte Carlo integration. You made anything other than Tesseract Vexitos? Come on. Come on. You know that. Algorithm Archive. So we'll do Monte Carlo in here. So if you want to learn more, here's a bit about it. So, but yeah, so I didn't put the Batman animation in here, but actually I did put it into laos.github.io. .io. Yep. So we have Batman integration here. Yeah. This is my first attempt at making something like the Algorithm Archive, and yeah, this is how I detailed how to make Batman Monte Carlo in C++. So yeah. The next video will be on Fractals then? Yes, so it should be on iterated function systems. Let's take a look at this visualization. So we have 3 points. 1, 2, 3. 1, 2, 3. 1, 2, 3. Yep, yep, yep. Okay, not bad. That is not as bad as I thought it could be. I think we need to maybe make it so the ball size also changes a bit. So we'll say jaw frame, and we'll also do ball phrase, ball size. What's the ball size defined as? I don't know. It's going to be equal to minus equals. Actually, I'm going to put this in to do. Because I have a lot of ball sizes to change. Okay, so we're getting there with the animations. Unfortunately, we need one more day for them, and so we'll do that tomorrow. I will come back at 2 o'clock p.m. Eastern Time tomorrow, and I'll be streaming from 2 o'clock p.m. to 6 o'clock p.m. Eastern Time. So that's when I'll be live. We wanted to raid someone at the end of stream. Try and quit. I want to play this animation one more time because I'm a big fan of it. But we're getting there. We are definitely getting there with this visualization. It looks super cool. I'm a super big fan. Man, that's so cool. Oh, I'm such a big fan. We have some stuff to do. But man, that looks cool. Okay. So that's it for that animation. Well, I mean, there's more to do, but we'll do it tomorrow. So right, that's it for that. That's it for now. We did a lot on today's stream. We started out talking a bit about Klima, and the Climate Modeling Alliance, the Climate Machine, all that kind of stuff. And we got a lot done there. We finished up a PR, figured out a long-standing bug. We then merged a PR and we discussed a PR about the algorithm archive. And then after that, we worked on this animation where we got 2 animations mostly figured out. I'm a big fan of all of that. I think we did a lot of work on today's stream, and so hopefully you guys will join me tomorrow when we do more cool animations for the algorithm archive, working on visualizations for the next chapter and the next video. Big fan. Okay, so let's go ahead and start that raid on Anthony Writes Code. So raid Anthony Writes Code. I was here for a few minutes and already have a fun project for this weekend. Thanks. Nice. So interesting, your content. Thanks for a good productive stream. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whenever time it happens to be your time. And I'll see you around next time for the next episode of Simuleos. Bye, guys.